Welcome to the Global AI Bootcamp. We're here from Brisbane, Australia, and today we have an awesome day lined up for the event. We're going to be kicking off actually the first presentation at 9 a.m. Australian time, Australian Eastern Standard Time. That means in 30 minutes we'll kick off the first presentation with Alessandro. And in the meantime, actually, I'd like to introduce ourselves. So we are the organizers as well of the Brisbane AI user group. I'm your host today, David, but I also have Sarat and JK with me. Hey, Sarat, how are you?
Hey, David, I'm doing well, thank you. As David mentioned, everyone, welcome to this virtual bootcamp. Please feel free to join us at the virtual bootcamp at this address if you haven't already done so. And hope you have an enjoyable day. Thank you.
What about JK? How's everything doing?
Yeah, I'm doing great. Welcome to the virtual AI bootcamp. And I think we have a pretty good lineup of talks, and everywhere from smart cities, cognitive services, starting with machine learning, and we have some exciting sponsors as well. So hopefully you'll enjoy today's bootcamp.
That's it. And actually, before we kick off, so we'd like to share with you pretty much a few things that we have in our webpage that you can visit whenever you want. What I'll do right now, I want to share my screen, and we're going to look at a few things that we have in Google Chrome. Well, this is loading actually. So the three of us actually were based in Brisbane, Queensland, Australia, and today the weather is really, really hot. It's already, I think it's going to hit around 30 degrees. So let me, window. Here we are. Cool. So this is our website, pretty much the Brisbane AI user group. So what I'd like to share with you actually is a few things if you want to have any information about the event. So first of all, if you're joining from YouTube but you want to opt for any of the prizes, you'll need to register to the event. So please come over here and click through Eventbrite. And so pretty much this year we have decided to run an online event. We're part of the global AI community. This means that the bootcamp last year, for example, it happened in many cities at the same time. But this year, due to COVID-19, we decided to run the event online and do it in a streaming, actually. On top of that, so we have a great speakers lineup today. Stefano just called me, actually texted me a few minutes ago. One of his clients has a major outage, and he doesn't know if he's going to join in time, but we'll have as well Alessandro actually covering that time slot. I believe that's pretty much business as usual, right, JK?
Yeah, I think so. We already have Alessandro waiting in line, so that's good. So we should be all good for the first presentation.
Awesome. What about, in the case, Sarat, have you suffered any client outages during the weekends?
I'm happy to report there's no client outages in the weekends, but I'll keep my fingers crossed it doesn't happen in the future.
That's a good one. Okay, we have an exciting program for today. Actually, we decided as well to run a shorter event. We have 4 amazing presentations. We're going to be kicking them off in 25 minutes. And at the end of the event as well, we're going to have prizes. So stay tuned for them. On the other hand, something that we cannot forget to mention, actually, this event wouldn't be possible without the support of our local sponsors, Queensland AI Hub, MOQ Digital, and BQ. Today we're going to be actually, we have a special guest from Queensland AI Hub in a few minutes, and we'll be covering as well what MOQ Digital and BQ are trying to achieve. Please, if you just joined the event, it'd be great if you can go to the website and read the code of conduct for our event today. And on top of that, if you have any questions, what we'll do is that you need to go to our YouTube channel where we have the stream and submit a comment with any question that you have around the event. And JK actually is going to be looking at those comments and making sure that we answer those questions. Next up, actually, so what we'll do today, we have a special guest, and it's actually one of our sponsors, is Queensland AI Hub. They have been supporting us along the journey while preparing this event, and what they're trying to achieve is actually amazing. So give me a sec, and we'll bring Steph, who is one of the leaders at Queensland Hub, to share what they're trying to achieve. And hi, Steph, how are you?
Hello, good, how are you?
Good, thank you. So first of all, thank you for supporting the Global AI Bootcamp, in this case, the Brisbane AI community and the Queensland community. And I know actually this was a last minute request. I think we agreed. We told you yesterday if you wanted to present something about Queensland AI, and actually you were really keen actually to wake up early on Saturday and run us through what Queensland AI is trying to achieve. So what I'll do, I'll share the Queensland AI webpage, so you can run us a little bit through what the objective for the company is.
Excellent. So thanks a lot for having me and letting me speak about the AI Hub. Really appreciate it. And yeah, we've enjoyed so far working with you guys, and obviously there's a lot of overlap in what we do. So for people who don't know, the AI Hub is based in Brisbane at the precinct in Fortitude Valley, but we are having outreaches all across Queensland and also connecting with people throughout Australia and the world. So even though we're called the Queensland AI Hub, we're not just for Queensland. And we were launched in May, so right in the thick of lockdown in Brisbane, but we still managed to run some pretty good virtual events. So the basis for a lot of what we do is to really build the AI ecosystem in Queensland and also in Australia. So our number one goal is to really build both the talent, the awareness of AI, and small startups and medium companies and even large companies who are utilising AI, building AI-enabled tools all across Queensland and Australia. When we launched in May, we actually had a datathon. So we invited, we had over 250 people register for that event, and it was completely virtual. And we had 18 different teams that were looking at different clinical data sets and trying to figure out how they could use AI or machine learning to come up with some deep analytics and insights and tools to support clinicians in their work. So that's something that I'm very passionate about because I look after the MedTech program, but we do service AI for all different sectors. So there's also people working in geospatial and agriculture. So essentially, at the AI Hub, we're not building out AI, but we're building events to connect people. And so far we found that really powerful. So as I said, with the datathon, we had 18 teams and we had over 150 people make new connections, so connecting AI practitioners with clinicians to solve real world problems that they wouldn't have done otherwise. We had a lot of feedback, from people saying, I wanted to do this for so long, but I never would have done it without this sort of event. So that's the datathon was run in June. We are going to have another one coming up next year. So there are a lot of events next year. We're going to have a accelerator that starts in March. It'll be announced early next week. And so that's for anyone who has an MVP startup using AI to come along and we can help them commercialize. On Monday, we also have a webinar. So we're going to be interviewing a clinician who has built her own AI-enabled app for diagnostics. So that's on at midday. So lots of different things going on. As you can see, yeah, we've got our website here, so you can have a look through the website. And probably at the moment, the best page is the Contact Us page, where you can get in touch with all the different people who are looking after the different areas of AI. And then also,
what's the sorry, Steph, because you mentioned the MedTech program. Actually, can you tell us a little bit more about that program?
Yeah, absolutely. So the MedTech program is again consists of a series of events and a network of people who are either AI practitioners and interested in working on clinical problems, and then also clinicians. So the next event that we have for the MedTech program is this webinar on Monday. Then we're going to have another medical datathon early next year. And the goal of that is, again, to connect people who have ideas and who want to implement those ideas and really start building them out. And then the accelerator, obviously, to really help those continue. As we are building out the hub, so we're still in the process of getting our fit out, we will then be, offering things like experts in residence and become a resource for people who need support in building out their AI-enabled ideas. The MedTech program is largely just focused on how can we enable the healthcare system to take up AI, and how do we do that safely and securely in a really effective way. So also looking at running education programs for people who are interested, but they might be a bit uncertain, they might be a bit afraid or hesitant on how AI can be used in healthcare, but we really want to run high quality educational programs and sessions for people who are just interested and want to know more, and then they can take it from there.
Okay, and for those ones in the AI community here in Queensland, Australia, so will you be happy if we tell them to pretty much, if they want to get involved with any of these programs, pretty much to drop an email at any of these email addresses?
Absolutely. Yep, more than happy to. Mine's on there, so happy for anyone to contact me. But if you contact anyone on that list, they'll get back to you and let you know what we have on and how you can get involved. And, we're for everyone. We're for people who are students, in primary school, all the way up to, high level, clinicians, or anyone who's, really an expert in their field, but just wants to be involved in this space. So, yeah, anyone's welcome to reach out and see how they can get involved.
Awesome. So thanks again, Steph, for getting involved actually and sponsoring the event. I think we'll be in touch in the upcoming months to help the Queensland AI community in different ways. And thanks again.
Perfect. Thank you very much for having me.
No worries. Bye.
Thanks.
Okay, guys, that was amazing. Actually, it was great to see how Queensland AI Hub approached us a few months ago. And they share a similar vision, and definitely they support us, which is amazing. Cool. So we still have for those one who just joined the streaming, we're going to be kicking off the first presentation with Alessandro in 15 minutes. He's already in the backstage, so I'd like to bring him online, but we're going to wait. Not yet. Okay, next up, actually, we do have a few more sponsors that are supporting the Queensland AI community. In this case, is BitQ and MOQ Digital. I don't know, Sarat, if you'd like to give us an update on BitQ, actually.
Yeah, I would like to just give a brief overview of what BitQ is, and thank them for being our sponsors. So BitQ basically are a professional services company. We are based out of Brisbane, Queensland, and we look after any data-related projects. So our motto is we help to make your data useful, regardless of what stage your data is in. So we provide governance, strategies. We do implementation. We do reviews, and we've grown in the last couple of years. So we started off with about 5 people. It's about 20 to 30 now. So it's a fast-growing company, and we've got some good clients on board, and we're completely happy to help you out. So if you're looking to do any data-related projects that includes AI, reach out, and they'll be perfectly happy to help you along your journey.
Okay, what's the best way for the attendees and those ones in the event to reach BitQ actually and to start any conversation about solutions?
So if you want to reach out to BitQ, there's a couple of options. You can drop an email to me, and I can forward your information onto the people at BitQ. You can go to the BitQ website that I've got listed here. The address is, I'll put that into the comments section, so you can you have something to click on. Just go ahead and just raise a conversation from there, and we'll get in touch with you.
Awesome, that's great. On the other hand, I think you are one of the experts, one of the leads architects at BitQ, right?
That's correct. So I work as the data strategist and a cloud solution architect at BitQ. So if you've got any challenges, yeah, reach out to me as well. So I'm perfectly happy to help out.
Awesome. Thanks for that, Sarah. Cool. That's amazing. Actually, it's great actually to have the sponsors. Running this event wouldn't be possible without the sponsors and the support of the local community. Today we have a great speakers lined up, and without attendees, it'd be actually quite difficult to run an event as well. We do hope actually that next year maybe we run a virtual event and we stream it online, but we'd like to go and run as well this physical event and catch up together, and when this COVID-19 era is over, so start pretty much going back to those physical events as well. And next up, actually, I like to cover actually our last sponsor for this local community. That is MOQ Digital. What I'll do, I'll bring their website online. And MOQ Digital pretty much they work in the data space. Even we're specialized in different industries like education, healthcare, government, utilities and transports, and many more. And pretty much we do work with data as well in the integration space or the data analytics space. If you were going to have any problems that you'd like to solve with data, we're going to be pretty much they're going to be there for helping you. I'm one of the data architects at MOQ Digital. So if you are looking for any help or you're trying to solve a problem that you currently have with data, or looking at implementing new solutions with cloud technologies, definitely we are here to help you. So if you want to contact us, pretty much again, so you can reach me in the social networks in LinkedIn, or send me an email, or come to the moqdigital.com webpage and send us an email, and we'll be happy to help you. Okay, so now we pretty much we had the opportunity to talk a little bit about all the sponsors for this local event. What I'd like to do next actually is to talk a little bit about AI. Okay, and the first question that I have for you, JK, what are you looking forward? What are you looking forward to be released in AI on 2021?
So in 2021, one of the things that I would love to see is that Brisbane actually steps up the game in AI. Like we have like something like Replica AI, where we have dedicated AI companies. But what I find with a lot of clients is they don't even think AI is an option. Or it's too expensive, too much R&D and stuff like that. And I want to kind of fix that so that more people are comfortable at least trying out AI, getting them roll out, have a human supervisor to make sure that everything works well, and slowly but surely get AI everywhere.
That's great, actually, and that's a good point, right? So if there are more AI projects in Queensland, definitely we're going to be able to upskill our game.
Yeah, and I think the important part here is AI is basically a spectrum. So you can have anywhere from something that just does a suggestion what you should do, and you can either take it or leave it, to all the way to full automation. And I think there's a lot we can do with just the first part, where we just do have a suggestion and just help people decide what they can do based on certain circumstances. Whereas the full-on automation, that might be something that once you already have enough knowledge about machine learning, about AI, and when you have tried it out for a long time and have good trust on it, you can then start thinking about automation. But a lot of people are already scared doing the suggestion part. So I hope with events like this, we're going to give people more confidence in AI, and also thinking about, hey, I think we can use AI to solve this problem.
Wow, that's an amazing point, actually. And what about you, Sarah? Is there any specific technology that you're looking forward to be released in 2021?
Not so much technology. I know that NVIDIA is releasing some new GPUs for people doing machine learning and AI as well. So I want to see a lot of the image processing capabilities that are out there now getting better and better, especially to help in the medtech field. Obviously, with the upcoming, with the new diseases that they're finding on a regular basis, having AI to detect them up front and raise flags early is going to be paramount. So anything to help with that, I'm quite happy to. I'm be quite keen to see what's going on.
Wow, that's a good point, actually. In my case, I'll give you something. So for you, JK, especially, what if we have a machine learning model or a robot that helps to convince business stakeholders to invest more in AI?
And AI for people to take up AI.
I mean, if you have good stocks that are AI and they're growing, I think that that way you can convince a lot of people to invest into it, even without thinking what they invest into.
Definitely. Having stocks in any company that is doing AI, that's a good idea, right? But we're not responsible for your investments as well. We need to say that. This is not professional advice. It's just
But I said it's not illegal advice. We are not lawyers or financial advisors.
Okay. So I'm cautious of time. Actually, we'll be kicking off the first presentation in 7 minutes. But I would like to raise one more question. Actually, it's for you, Sarah. Maybe start with you. So, what was your favorite piece of AI news this year? Something that happened in 2020 that you were, wow, I like this technology. I like this.
I don't know specifically if it happened in 2020. But one of the pieces of interesting pieces of thing I saw was Google releasing, Google AI releasing a virtual assistant that will go out and book your haircuts for you. And that I thought was a lot of, it's very interesting what you can get an AI computer to do with machine learning that you take typically for granted, that somebody will call in about booking a hair appointment.
Wow, yeah, that's a good point. What about you, JK?
Yeah, so mine is a little bit interesting in a sense that my focus as Microsoft AI MVP is to share the knowledge of machine learning. And you might see it here. I really love ML.NET. And for this year, I really love what they did with the ML.NET model builder. It allows me to teach people get into machine learning faster, get more developers on it, and they can experiment now even easier than ever before. Like, I really need to change my demos because they patch up a lot of things to make developers' journey to machine learning easier. So while it might not be something really big, as Raf mentioned, I think it will have a big impact to the developers that are starting with machine learning.
Yeah, that's a good point, actually. Really good point. my case, I think that seeing all this. So all the different cloud providers, pretty much, they're releasing new features pretty much on a weekly basis. That for me was having them to release new features pretty much every week and competing between them, right? You see the big cloud providers, they're competing between them. And that's it's a good thing for us, actually, to have options and to have more and more features. Okay, so what we'll do next? Actually, the reality is that we have a lot of more questions that we can go through.
Yeah.
But I don't want to forget. If you just joined the stream, please go to the virtualaibootcamp.com webpage. Have a read at the code of conduct. Have a look as well at the agenda for today. We have amazing speakers lined up with amazing, awesome presentations. We also have the local sponsors for the Virtual AI Bootcamp. We have Queensland AI Hub, we have VQ, MOQ Digital. Please go and visit their web pages. And before I forget, actually, one thing I'd like to highlight as well, if you want to opt in to the prices at the end of the event, you need to register for the event. So you need to go to the webpage and register in the Eventbrite webpage. So only
showing the meetup URL.
That's a good point, actually. Yeah, because the three of us were the organizers of the Brisbane AI user group. I was going to forget this one. Thank you, Jake. The three of us were the organizers of the Brisbane AI user group. So actually, if you're looking to continue attending events, please go and join this meetup group. At this stage, we're running virtual events. I don't believe that that's going to go away even after post-COVID-19 era. What we'll do is we're going to have a mix of virtual events plus the physical events in Brisbane. But yeah, if you want to learn more about AI, if you want to join more events, go and join us, our Brisbane AI user group in Meetup.
One other thing with the Meetup group is we're running it vendor agnostic. So we've already had sessions from Microsoft, AWS, and Google. And we're looking to bring you more diverse talks as we go along. So yeah, so it's if you don't know any of those products or vendors, come along and join us. If you've got ideas of what else you would like to see, please let us know, and we're happy to organize them for you.
Yeah, and also remember that the Brisbane AI Bootcamp, the Virtual AI Bootcamp, is part of the global AI community, and without their support in the back end, without Henk and Willem supporting us actually to be able to stream this event online, it was going to be really difficult for us to run this event this way, actually. Next up, so we have Stefano and Alessandro. Stefano, actually, he has some problems with the client outage, but Alessandro is already in the outage. We're going to be kicking off that presentation in 2 minutes. So I'd like to thank JK and Sarat. Thank you, guys. And what we'll do, actually, if you're ready, we'll go for a short break and bear with us. So in the meantime, we prepare the first speaker so we can kick off the event. So stay tuned. Wow, Alessandro, nice to
Hello.
have you here, actually.
Yeah, hello everybody, and nice to meet you. First of all, thank you very much to invite me in this event. Oh, it's very. I hope that will be a very nice event. That is my first time in Brisbane Bootcamp. Yeah.
Okay, Alessandro. So where are you based?
I'm based in Lucerne, Switzerland. It's midnight. Now we have 3 degrees. The mountains are white with the snow. I think that the weather is a little bit different from Australia, from your Brisbane city.
Yeah, definitely. Today I think it's going to be 30 degrees, and here, as you know, it's 9 a.m. only.
Yeah, I know. And yeah, you are very lucky. Well, here it's also cold, started to snow. Yeah, it's very yeah, but it's winter. Yeah.
Yeah, understand. Okay, definitely. Thank you actually for getting involved with the Australian community with this event. I know that right now, so Stefano is going through some sort of client outages. I hope luckily we work in IT, so if it's not a hospital IT infrastructure, I hope everything is fine.
Yeah. Stefano unfortunately received a call this morning from a customer and skipped this event. Unfortunately, he has the demo. I have already the video, and I hope that I know that it's not the same, but I hope with the video you can understand better what we are explaining during our session.
No, definitely. And tell me one thing. How do you come up with this case study actually with AI machine learning?
Yeah, if it's possible, I introduce a little bit myself and my company. I share the screen, but can you see
Let me bring it. Yeah, let me bring it.
Perfect. Okay, good.
Okay, what I'll do, Alessandro, pretty much, I'll let you. I give you the stage to you. Okay, I'll leave it with you.
Yes. Okay. Perfect.
Thank
okay. Yes, I am Alessandro Graps. I am CEO JOULEHub in JOULEHub and CEO in AI Brain. That's are my connection and my contact if you need. With me, I don't know if he can enter in the second time, but I hope, but I think no. There is also Stefano. Stefano is our Australian partner, and he is the expert and guru in Microsoft architecture, in augmented reality, computer vision, etc. Before to start, some introduction about my company. Why we talk about? We think to talk about this kind of case. We are an R&D company. We work with university, with private and public customers. We are specialized in digital transformation. With machine learning, augmented reality, virtual reality, mixed reality, all cognitive system. We are an electronic laboratory where we produce and design our circuit board. And we are specialized in automotive, packaging, energy market, robotics sector. Where we are in Switzerland, in Lucerne. Now I am in Lucerne. We are in Italy, but we are also in Australia. That's why we decided to participate we started to participate in event in Australia. because we open in beginning of this year our new office in Australia. We decided to follow these kind of events. As I said, I am also CEO in AI Brain. AI Brain is a virtual reality, augmented reality company specialized in design of machine learning, virtual reality, cognitive system, augmented reality projects. We work in different sectors, and we decided to open this company because our customers start to ask us this kind of project. What I wanted to do to talk today. Today, I would like to discuss with you the smart city and how the technology can change our lifestyle, can help us in different situations, and how the technology can help. When we talk about smart city, we always think about a home sensor. For example, an apartment with a sensor for humidity, temperature, for check and control our light, etc., etc. But there are a lot of different dimensions inside the smart city. For example, economy, because when we talk about smart city, we have also to talk about the change inside the economy, and mobility. How can people move in an eco-sustainable way, or to prevent energy consume? Environment, build office, public office. People, how can people change in better way the lifestyle, or how can people can have all the same opportunity? Normal people, people with a disability, Kinder. Sorry, Kinder in German. I'm sorry. Young, old men, old people, etc., etc. And government also, how can manage a city is changing. But why smart city? We have now the situation because we need smart city. We have involved in COVID virus, and we have, for example, we starting to thinking about home working, remote working, and that is a change in our life. And the question is, but did we were we ready about this change? Because what we have here in Switzerland during this COVID, all people started to work in home at home, and we had a lot of issue, a lot of trouble with the internet connection, with the connection with the offices, because not all people can connect in height level internet connection, or they cannot use VPN, and that's why we have to talk now, and we have to continue to talking about smart city, or we can talk about smart city because we are thinking on climate. The climate is changing, and we have to create a city where we can manage these changing. For example, we can thinking about Italy. Until 5 years ago, in Italy, we never have a hurricane in the summer time or a bigger storming. But in the last year, we have always a small hurricane or big storming during the summer, and that's is change. We are not ready for this kind of event, and we need to understand how can change that. We talk about security. Security is first our issue around the world. Security it's not related only with security about a person, but security also during a pandemic situation. For example, now we are not connect with whole, and that is a big issue. We are trying to drive this changing, because we have 5 points to discuss. Urbanization, the population are changing. We are growing. We need to understand different way to build home, house, etc. As I said, demography is changing. In Italy, for example, there are a lot of old people, but in other countries or continents, there are more young people. We have to create a calibration with these different situations. Lifestyle is change. As I said, we have now a demonstration how our lifestyle changed. We have in a remote, we cannot go out from our apartment. We have children at home. We try to work and to make a meeting with children that are playing maybe near our desk. And we have to find a way to calibrate, to balance life, work in the unique space, in unique location. And as I said, also climate is change. We have every day the situation. Maybe I remember last year the fire, the bushfire in Australia, or the hurricane in Italy, or the California fire is changing. We have to find a measure for create sustainability and to try to live together with the event and with people. But what is what is the main actor inside a smart city? Inside the smart city, the main actor are 3: IoT devices, all sensor, camera, life cycle, satellite, etc. Cloud, because all information need to share and to be in a way where in a place where we can get, and in the big data. Without information, we cannot create anything. We cannot analyze anything. We can have always a big, fantastic technology, but without information, that doesn't run. But how can manage this this smart city? For us, the smart city must be a citizen-centric. The citizen inside are the people that can decide how can update a smart city, because a smart city meaning to update every time something, not only technology, but culture, process. And the unique people that can understand what they need are the people that live directly inside the city. And that is our process that we can try to use in our project with, for example, Lucerne. The first point is involve people to share valuation, ranking, or needs with the governance. Identify what are the main issue or main update to do in the city. Create always something to have always a better quality of life. Share information, because as I said, without information we cannot do anything. And always we have to give the opportunity to share information. Create a ranking about this decision, and of course create a city indicator, a manifesto, or a guideline that we can replace and replicate in the other city. That is an example for infrastructure of a smart city. We have building, offices, public offices, apartment, home, all connecting with a cloud, all connecting with people and with other infrastructure. Because in this way, for example, I can, if I don't feel very well, the hospital can understand, and that I don't feel very well, and maybe they can I am not able to call police or doctor, and in this way, automatically hospital or doctor understand that I need help. And as all must share with the other infrastructure, the other sensor, because all need to communicate together. Without communication, without a connection, a community doesn't exist. That is our smart city concept. What is our smart city concept? For example, we can create a structural health of building, because we can create a first act, for example, inside our building. We must check air quality. I think in a country or in a city where there are high level of smoke, maybe with a sensor or with a control, we can understand if I can go out, or I can work at home, or I can have to change my appointment. Traffic congestion, a way to centralize all traffic and understand what is the right route for me to move without find traffic. City energy, we talk about climate change, but without change also our energy, our consumer, we cannot think about to eco-sustainability plan. We have to create and add predictive system or system that can auto-calibrate to give always high performance with the best energy use. We can think about smart parking Or we can think also on smart light or automation of public build. For example, we are creating, we are using machine learning, a cognitive system to create a way for people with disability to move around the public office without assistance. And that is a good way to do to thinking about a better world. And as I said, citizen security like security on the road, security in my apartment, security from natural event, security for all. When we talk about smart city, there are maybe a big topic that people started to thinking. It's security. I give all my personal information. I give all my, information about my life, my style, etc. But I need to save and to create this security. The privacy, first of all, is a big issue when we talk about smart city. And when we try to create something with where we use data, we try to make some we try to use some technology like blockchain, for example. And what we are to do, we have to identify, create operation process to manage device, to manage information. We don't want to, this information can use in a good way. I think always to use this information in a good way, in a good project for people. But maybe there are people that can use that for bad situation, and we have to be trust for with our data. And what is the security challenge required? The security challenge required is to create a prevent attack from these to lost our data, detect attack and detect fraud on our data. And the response, we have to react in a quick way if we have this bad situation. But as I said, we have a technology. We have a blockchain. Blockchain, we are using blockchain in our project, in our smart city project or finance project, where we need, where we have to create something to protect our sensible data. We use that and in supply chain, in distributed cloud storage, in virtual storefront, in payment and money transfer, in smart contract, in notary services. And we are creating, we are not creating only security for people, but security also for our sensible data. I prepare a video because it's most important also to understand the technology that we can use to do that. That is our some example that how can augmented reality, virtual reality is used inside our company. it's a short video where, sorry, first of all, because it was a German video in German, but I don't find the English version. And that's what we are making for with the technology. How can technology help us for in a smart city? We have, for example, augmented reality to follow a route inside a city. We have augmented reality to make training in company and in the school also, because we had our students that are at home for a lot of months during this lockdown in for COVID, and augmented reality help to make all these kind of laboratory that it's impossible to do in at home without machine and device. For example, we can think about electronic engineering school, where we create a software to teach how can work in a microprocessor build, and that's all. And that's all use augmented reality. And as I said, we use technology for disability. We talk about smart city. We talk about security in smart city. We talk about technology. But how can use in a real case this technology together? We thinking that all people in a city must have the same opportunity. We don't want to see barricade in a city, in a public office. We don't want to see people that have a problem to cross the street, for example. We have a technology. We are talking about smart city. We must use the smart city for help people and create a better, comfortable zone or better lifestyle. We are working, as I said, in pro bono project with charity and charity association and company, where we try to create smart wearable devices. We use augmented reality, mechanic, robotic, artificial intelligence, and that's what we are trying to do. I am a fan of Star Trek, and I started to Star Trek when I was a child, and we wanted to create these glasses. It's not maybe in the future we have, but now we have the technology to create something similar, to create something where the people can use and can live in a better way. That's our project, our free project for charity, university, and association. We have 3 main projects. The first is Vision. It's system for the visually impaired, where people can walk across the street without fear to obstacle, without make incident. The system try to guide the people, and we try to connect all. We try to connect traffic light, public offices, road light in the street, GPS system, camera inside the city. The other is movers, is our smart wheelchair where we use augmented reality and artificial intelligence and machine learning to create autopilot wheelchair. And of course, we have exploring. It's an extension of the vision that is a walking cane for visual impaired that has different sensor inside. I would like to talk with you about our movers. A mover is a system that we create with the Microsoft with the Microsoft platform and devices. We are using HoloLens. We are using Microsoft Azure, Microsoft Machine Learning, all Microsoft Computer Vision, and all Microsoft Artificial Intelligence. These devices, this platform, we are creating this platform to try to give an happy experience, free and quick way to people with disability. That is the electronic diagram block. We are using two parts inside the project. The first part is all sensors. Sensors are related with understand the distance, for example, between an obstacle, ultrasonic sensor. We have accelerometer to understand our velocity to walk. We have a controller, our CPU, where all information are comparing between imaging and between sensors. And of course, we have alarm. Alarm is a buzzer, vibration or GSM, GPS alert. That is our algorithm. It's most important to understand because we are using two different data. Value from sensor and images from the camera. We get all of this information and we compare because, of course, we have analyzed the imaging with all obstacles, but we need to understand the distance, for example, between a person and obstacle to find the right direction. That is our prototype. Inside, we included ultrasonic sensor and other sensor, but the main is ultrasonic, a depth camera to acquire imaging information, cloud where analyze and share and storage, our data, and augmented reality glasses to get AR rendering. Of course, we have also an headphone because in this way we can give a noise on alarm, sound alarm. How can work? We get the images from the camera. We have the place, the image for the place. We make a rendering, a 3D rendering for the images to understand what kind of obstacle we have. These obstacles are saved inside a Microsoft Computer Vision. We have value from ultrasonic sensor. These information are compared, are analyzed together and compared. In this way, I can understand that there is, for example, a desk or a box, a bag on the road, and what is the distance. And in this way, there are a real-time calculation for our artificial intelligence that give us the right direction to move. What is the main components? As I said, is the ultrasonic sensor. Ultrasonic sensor give us get and send us all distance between a person and object in this case. We have a big issue inside. What is the right height where we get the right position for the camera? Because we have to understand what is our vision. We have to understand what is the right height for the people, because there are different heights for people, and we need to check also what is the position and the angle when people walk is different. That was a big issue. We thinking about height between 1 meter and 65 and 1 meter and 89. And in this way, we can get all information about our route. With this information, we started to create different coordination from the camera. What is person? Coordination for pixel, because we make an AR and 3D rendering, we get all obstacles. Image coordination to understand the place, and the direction, the velocity of the person, and we create a matrix, a mathematical matrix, to get the right direction and the right movement that person must do. As I said, that is our algorithm to analyze and compare imaging with IoT information, because we are talking about IoT also. All value in from sensor are compared with images. And as I said, we make also a rendering, rendering to understand where is the obstacle, to create imaging in something that the our artificial intelligence can understand, can learn, and can analyze. That's ways realized with the Unity 3D, and we use that to adjusting the texture coordination of the depth machine to have a right, most better precision for the coordination. I had a demo, but I don't have the demo because Stefano is not with me, and he has a demo. I am very sorry for that. And yeah, we are trying to working to create a world, a better world, a better situation. And we try to use technology, machine learning, artificial intelligence, augmented reality to solve a problem inside a city. Thank you very much. I finish. If you have any question, I'll try to answer.
That was a great presentation, Alessandro, on all the things that actually you're trying to help to achieve with AI and machine learning to help actually people, right?
Yeah,
so
exactly.
It has a huge impact. So first of all, if any of the attendees wants to know more about these products or this solution, what's the best way to reaching you? What's the best way for them to contact you? Sorry.
For contact me, yes. Wait a second. I have if run my laptop. That is a way to contact me. We have in Switzerland, as I say. You can see our website. Or when it's possible, I invite you to visit our laboratory in Australia, in Italy, and in Switzerland. And I know that it's a long travel, but my goal is when we can go again to Australian, to move in Australian and make face-to-face this event and present our best solution.
Definitely. We do have a question actually from Gary Lewis. And he's asking actually, we know that Stefano today, he has some problems with a client, an outage, but will it be possible to publish the demo?
Of course, yes. I'll publish the demo, of course, in the next day. Now it's 20 minutes to 1 o'clock a.m. in Switzerland. And maybe I have to go to find my son where he is.
Yeah, we understand that. And the next question, actually, what are some of the challenges? So you mentioned some of them. It was about the where people, the angle for the
Yes.
for the
challenge.
For the glasses, but so how do you overcome that challenge?
Yeah, the challenge, we have a lot of challenge in this project. The main challenge is the first challenge that I had is the angle. We resolve to make tests with real people with the problem on the eyes. The second issues that we have is we are trying to create different architecture for our machine learning, because each city is totally different than the other city, and we have to create a lot of different machine learning and artificial intelligence for every city that we are trying to work. And at the end, we want to create a big black box, big machine learning to analyze all the results from these other machine learning. In this way, we can understand, we can create a standard for the city. Because, for example, I live in Lucerne. Lucerne is totally different from Zurich. And Zurich is 30 kilometers from Lucerne, and the movement is totally different. The location for office is different. Or we can think about Venice. Venice is a city on the water, and we have also a different way to travel and to route inside. We need to understand how can implement this situation.
Yeah.
Maybe they ask how can HoloLens is now available in Australian, correct?
That's a good point, actually. So
okay.
you need to take those things into account, right? When you're deploying that solution in different countries, or you'll be able to shift, let's say, to pack your solution in Europe and then shift the solution to other countries.
Okay, we have two situations. The first situation that we are creating our smart glasses, because HoloLens are fantastic, but it's not available in all countries. And we want to create a more light or quick and fast smart glasses. The second is how can work. Of course, I have office in the Australia, and for dev, I get here in Europe our HoloLens and send to Australia the HoloLens too. that is a big trouble that I hope that Microsoft resolve in a quick way, because there is also another official way.
Yeah.
There are possibility to, if you have an address in the United Kingdom or in Italy, you can get these HoloLens and send it to in Australia, but it's not an official way. I hope that that will be available in all country soon from Microsoft. But I think that for bureaucracy, governance, it's very difficult to do.
Yeah. Do you feel that with the same subject, do you feel that within Europe it'll be easier because they are under, some of the regulations are the same?
I really don't know, because as I said, for HoloLens, for example, here I am in Switzerland, and we are not in Europe. We are extra community for Europe. We have a lot of issue to get HoloLens. Receive our HoloLens in Switzerland arrive. These are available from this month. Before we work for HoloLens because we have office in Italy. Italy is in a community Europe, and it's possible to get HoloLens in Europe. Switzerland, in Switzerland we had the problem until last end of month. From November we started to be available HoloLens 2 also here in Switzerland.
Okay. Another question is, would it be possible to share? So, if you have any key outcomes that you're going to deliver with your company in 2021, something that we need to keep in mind or have taken into account?
Yeah.
Awesome. So that's great. So thanks, Alessandro, for those ones in the stream. So if you want to contact Alessandro, know more about the solution or the products, there you have the contact information. We really appreciate your support to the Australian AI community.
Thank you very much for the opportunity.
We're really sorry that Stefano couldn't attend this session. So we'll do pretty much, we'll go for a 7-minute break and we'll come back with the next speaker at 9:55. Thanks a lot, Alessandro, and have a good night, actually.
Yeah, thank you. A good week, good Saturday. Good week.
Okay, take care. Bye.
Bye.
So for the attendees, we'll come back at 9:55 with our next presentation with Martin doing an introduction to Azure Cognitive Services. Bear with us and stay tuned. Good morning, Martin. How are you? I think you're muted right now. I think you're muted. I cannot unmute yourself.
Oh, sorry about that. Yep. So
How's everything?
unlike Alexandra, the last presenter, I'm actually in Brisbane. Great to be here, David. First time I've spoken at the AI Brisbane Bootcamp.
Yeah, that's amazing, actually, and it's great because you moved just before COVID-19 era. You moved from New Zealand to Queensland, right?
Very nearly. So I moved from New Zealand to Melbourne about 5 years ago. I moved from Melbourne to Brisbane in January. So very, very timely. Got out of Melbourne in time. Spent about 2 months here and then a bit of lockdown. And so still exploring the place, and I reckon I will be for the next few years.
Okay. But we need to ask this question. So far, do you like more Queensland than the cold and crazy weather in Melbourne?
Well, yeah. Queensland's got a lot going for it. Like, I mean, it's a huge state. Great weather. We actually drove up to Cairns since we've been here. Big drive there and back. I guess the only real thing that takes getting used to here is it gets light really early in the morning, especially in the summer. I was up at 5:30 this morning. Yeah, crazy.
Yeah, that's a good point, actually. I feel the pain as well. Yeah. Okay, cool. So we have lined up a great presentation about Azure Cognitive Services. I don't want to take more of your time. So what I'll do, I'll leave you in the stage, and good luck. We'll enjoy this topic, actually.
Okay, thanks a lot, David. Thanks a lot. Okay, so this is introduction to Azure Cognitive Services. Basically, I'm going to assume no knowledge. I know we've just had a presentation about digging into some of the nuts and bolts of AI, but this presentation itself assumes like no knowledge at all. Even if you've got a bit of knowledge, you should be at home. So let's get into it. So the flow of the presentation is, so I'll introduce myself first. I'm Martin Catherall, past regional mentor. They do database stuff, things like that. That's kind of my go-to kind of task, if you like. And I'm an MVP on the data platform. So I've only really got into AI myself over the last few years. And the sort of pathway that I've chosen, I kind of had to find my own feet, and I'm kind of using that as an example to share how you can maybe get into cognitive services and take your first steps into AI a lot easier than I did. Because I guess one of the things that we all struggle with when we come to a new technology is finding our feet and finding that point that's good to begin at, rather than beginning at a certain point, then realizing it's not so great, starting somewhere else. And through iteration, we eventually get to the right place where we can start. But so this presentation is basically going to be in two main sections. We're going to just look at an introduction, see a few examples around AI, some quite basic stuff, but quite interesting. And then we're going to go on and look at the AI components through a series of not necessarily demos, but working examples. Now, the code I'm going to use is from a very well-known site, some good resources that are available right now on the internet. So the code's literally there now. You don't have to wait for me to upload it or download it. You can like literally play with it as we speak. Or just bookmark it, and over the next weeks, months, whatever you choose to do, you can go in and play with it. But we'll come to all that later. We'll just hop into what is artificial intelligence. And I guess at its core, it's sort of, it's not doing anything really that a human being couldn't do themselves. However, it's obviously doing it a damn sight faster than you could do it, and at speeds which is like unimaginable to any human being. You only have to look at things like, say, scanning number plates, going through a toll, going over the Gateway Bridge, say in Brisbane, picks up your number plate, makes sure you've got a scanner in the car, goes through your bank account, takes money off you, all kind of magically happens in the background. So obviously you could do that yourself, but while you were writing down someone's registration number, another 50 million cars would have gone past you, so to speak. So other things we can do is detect abnormal behavior. I was in Seattle a couple of years ago and I purchased at the bar 3 cans of beer. And now, unknown to me, well, at the time I got a text straight away off my bank, which I ignored. But what had actually happened was they'd stopped my credit card, and what happened is I literally just paid for those 3 cans of beer with my credit card. And unknown to me, the cashier had put that transaction through multiple times. And as I found out later, like 13 transactions had gone through, and they'd gone through fine, but my card had been stopped immediately. So that's an example of detecting abnormal behavior. So I guess we've already seen vision capabilities, reading number plates, looking for faces in crowds at airports, locating specific individuals, well-known celebrities, and things like that. Text and language is a huge one as well. Not just recognizing handwriting on a piece of paper, being able to talk. And some of the voices that are now in AI are really capable. I mean, if you even think back a few years ago, the voices that accompanied your GPS were quite broken up, and you could tell they were fake voices, so to speak. But now we can literally have computer systems that can imitate kind of me talking. And then that just goes on to holding conversations. Obviously, we've seen things like bots that are on websites for our banks. They give the impression of real people, but behind the scene, they call things like Katana or Siri or whatever. I'm sure the Commonwealth Bank have got one. And they can be quite helpful. Not totally helpful at this stage, but they can be refined to answer questions more freely and that sort of thing. And the power to do all this is really at your fingertips. Even as Sorry to interrupt you. So one of the attendees saying you have the stop sharing button there. If you can move it to the right side or out of the screen. Sorry, say that again, David.
You have the StreamYard option there that says stop screen sharing. Yeah, so if you can move it outside. Right. Yeah, that's it. That's it.
I'm sorry about that. Yeah, okay. I actually seen that there myself, but on a lot of platforms, even though the speaker can see it, the attendees can't. I didn't realize that was in people's way. I'm sorry. I apologize. So all those things that we've been through are literally at your fingertips. As even as a novice, you could probably sit down today, and we'll actually work through some examples in a little while. I've seen things like computer vision, maybe an anomaly detection, and all these things. So I'm not going to really touch on the machine learning part. I can share, speaking after me, is going to dive into Machine Learning Studio, and she'll probably show you some more of that. But effectively, most of this artificial intelligence has got machine learning in the background. And a lot of those modules are actually wrote for us in cognitive services. And so we can just go and grab, say, a face API or a handwriting recognition API, OCR. Now I'm calling them APIs, but they're actually just pre-built components that you can go in, create. You need some keys to access them, maybe like connection strings that most developers would be used to access things like databases and that. And then you can just plug in pictures or whatever, train models without writing any code at all, and have access to all these wonderful things. So you just been through basically examples of what anomaly detection, computer vision, natural language processing, and conversational AI can do. But as you got more into AI, one of the interesting things that I found, and we're not going to touch on deep learning here, but this particular example was really interesting to me. So imagine you and your friend sat down to play chess. Now, you didn't know anything about chess, you didn't know the rules or anything at all, but you each had in front of you a piece of paper that told you the rules. Like basically told you that king could move here, where the rules of chess. So you and your friend could sit down and you could work out over time how to play the game, and over time you'd become very, very proficient at it. However, computer systems can do that sort of thing in like sort of an unbelievable time period, like almost seconds, where they can start off not knowing anything about chess in this example. They'll play each other, analyze the rules, work out the best moves, and within next to no time, they're playing like countless games in seconds and becoming so good that they're good enough to beat like the world chess champions. Sort of thing that even like 10 years ago, when we were talking about a computer called Deep Blue doing this, it was kind of a bit hard, and it was possible, but not that imaginable. So there's some of the things that obviously we can do with AI. Another good example is curing diseases. For example, a patient who's got something obscure wrong with them, we can take their body metrics, maybe run them through a series of algorithms that knows about every single illness known to man, basically, and make a diagnosis really quick. Now, obviously, that technology is probably not mainstream at the minute, but it does exist today in some quarters, and I guess it'll become mainstream in the long run. So I've got in front of me at the minute just a brief diagram, kind of just a bit to outline how my path was into AI. Now, I've got a SQL background. I'm a data person. I've been doing data for nearly 20 years. So the big blue circle in the middle is like a data engineer, but you could replace that with a data anything you like. In fact, you don't even have to replace it with a data anything you like, because most people are totally familiar with data in general. But if we look around the side here, we'll see the AI roles, and there's a huge crossover. Well, this diagram doesn't show a huge crossover, but crossover is bigger than this alludes to. AI developer, AI engineer, and data scientists, and they've all got intermingling kind of crossover. So knowing a little bit about one and a little bit about the other is going to be quite beneficial for you. And the examples we're going to see very soon will make that obvious. So I guess to kind of start off with, I wanted to show an application that's available on iOS and Android. You can download this right now. In fact, I'm going to show this on screen. It's a 1-minute video. I'm going to post it I'll post the video link in the comments as well, but I will just open that link. Like I say, hopefully the sound will play. It should very well play. Just flick over. Here's. Right, I'll put that out to full screen.
Seeing AI is a Microsoft research project for people with visual impairments. The app narrates the world around you by turning the. Seeing AI is a Microsoft research project for people with visual impairments. The app narrates the world around you by turning the visual world into an audible experience. Point your phone's camera, select a channel, and hear a description. The app recognizes saved friends.
Jenny near top right, 3 feet away.
Describes the people around you, including their emotions.
28-year-old female wearing glasses looking happy.
It reads text out loud as it comes into view, like on an envelope.
Kim Lawrence, P.O. Box.
Or a room entrance.
Conference 2005.
or scan and read documents like books and letters. The app will guide you and recognize the text with its formatting.
Top and left edge is not visible. Hold steady. Lease agreement. This agreement
When paying with cash, the app identifies currency bills.
$20 US.
When looking for something in your pantry or at the store, use the barcode scanner with audio cues to help you find what you want.
Campbell's tomato soup.
When available, hear additional product details.
Heated microwave bowl on height.
And even hear descriptions of images in other apps like Twitter by importing them into Seeing AI.
A close-up of Bill Gates.
Finally, explore our experimental features like scene descriptions to get a glimpse of the future.
I think it's a young girl throwing a frisbee in the park.
Experience the world around you with the Seeing AI app from Microsoft.
Okay, so that was an example of basically an application that Microsoft have put together, which relies on AI. Now, clearly that's aimed at people who have difficulty seeing, but I'm sure you can see the possibilities that this can bring to you in your everyday lives. One of the things I used it for, like I was saying to David before this clip, we were on a road trip up to Cairns, and we obviously seen a lot of touristy things and that, and I'd take pictures of the signs, and then when we were in the car or something, I could get them read out loud to me about where we'd just been and that. So that's kind of an example of how you can do this. And this technology, although this has probably been enhanced in that by lots of professionals, is available to you inside Cognitive Services right now. So before we move into having a look at code and that, Microsoft have got a lot of responsible AI principles, and there's 6 of them here on the screen. And privacy and security, fairness. We don't want to bias the system, especially if it's doing something like it's involved in the legal system. Biasing that could be fairly not great. So being transparent about how it got there, not disadvantaging certain people or certain groups of society, is basically a principle of AI. So there's a link down the bottom there to something called the Face API, and we're just going to go over and have a look at that. Now, you'll actually see up the top, there's a disclaimer there saying that anything that's uploaded is not going to be used for any kind of legal stuff at all. And that's kind of only appeared over the last few months and that. But so this is about the Face API, which we'll have a look at in our demos very soon. But this documentation is quite advanced, and there's all the things you need here to get started. You'll see there's quick starts over here, tutorials for using SDKs and things like that. And this is particularly for the Face service. And one of the things I'll just generally point out about documentation is there's a link down here. It says download PDF. If we were to click on that, which I'll just do briefly, I won't download anything. This will basically give you the whole documentation set as a PDF. So it's sort of easily searchable for you. Might be a bit better than navigating it. But if we just go back one level to the Cognitive Services main screen, we'll see that Cognitive Services is basically a suite of applications. So Cognitive Services itself is kind of an umbrella term for all the smaller services that exist within the wider product. So we got things like computer vision, custom vision. You might wonder what the difference is between them. Custom vision, I kind of think about it's more where you train the model yourself to identify, I don't know, fruit or whatever it is. We'll definitely have a look at one of those examples. We've got faces, where we recognize faces, forms, videos. We can recognize faces and objects and things like that within videos. Lots of language understanding. Now, Microsoft have got something called LUIS, which is language understanding. And that's taken the conversational AI mantra kind of quite far, and it's built into something called Q&A Maker, which is basically a knowledge base. Lets you create a knowledge base yourself, either using, say, documents that already exist, or by slowly over time refining questions and answers you've got off your customers, rather like some of the bots do at the moment. Speech services, similar. And then things about decision making, we see an anomaly detection. Content moderation is interesting. We can actually, point our services at pictures, and they can say, has it got adult content there? Is it a bit racy? Is it relevant to children? That sort of thing. So these things are getting really, really advanced indeed. So that's just the Face API that brought us into this screen. But then we went back and looked at the cognitive services suite as a whole. So that's like a great web page that we can go to in general. So we should just stayed on that screen and looked at the computer vision. So rather than me actually perform code, we're going to look at code very shortly, but I've kind of took the approach that it's better to show these things using examples that already exist, that you can go and play with yourself kind of immediately. So this is showing like the computer vision API, if you like. So we'll go right up to the previous steps, and all it's going to do is analyze these images here, different images. So go to the next step, and it's going to just read text off the images. So we'll pick an image, say this one, and obviously you might be thinking, yeah, that's some sort of trickery going on behind the scenes, but what's actually happening is the cognitive services reading that handwriting and obviously telling us what's there. So here we've got one here, college tuition, and there's various other things, recognizing people's faces. Now there's a specific API in here that sort of extends the Face API and to recognize famous people. Obviously you can get it to recognize you or your friend, but you would have to train the system yourself to kind of recognize you or recognize your name, and that is perfectly possible. So recognize famous landmarks, famous landmarks, and and that sort of thing is like just built out of a box for you. So and what we get with the objects, how obviously this is a visual display, so some quite some objects that are very common, and around them is what we call a bounding box. And if you were to build a application to do this, what would be returned would obviously be not a visual, would be some sort of JSON, and in there it would tell you the coordinates of the bounding box, what that object was, or what the system thought that object was, and what kind of accuracy was attached to that object. So in this case, the JSON might say to banana, it's been trained on a whole load of banana images, and it's 99% certain it's a banana, whereas same with an orange or same with an apple. And then a very similar sort of thing with people. So here we can see it's obviously identified a person over here, and then to the right it's took that a bit further. It said, yep, this is a person. It's put a bounding box around their face, took an educated guess at their age, identified they've got jeans and footwear on. So it's took that to the next level. And then in the graphic further to the right, it's took it one stage further again. Again, we can see the faces around the bounding boxes around the faces. And it's done what's called sentiment analysis. So it said, obviously, this person's looking happy and 75% accuracy. And this other person further over to the right is looking happier still. And we've got like a 92% accuracy there. And then we can see that when we can see this has got what we call tags. So when this has been trained, images have been uploaded, we've tagged those images, the computer in the background has matched those trained images to images that are in the picture and basically regurgitated their tags. So I'm sure you can see this is probably not doing anything that you yourself couldn't do as a human being. Basically, that's all AI is, imitating kind of cognitive ability to detect things and just do things a whole lot quicker, like many million times quicker than you could probably do them as a human being. And so the possibilities of this stuff are obviously endless. As was pointed out in the last video, the last speaker, this can be used for great things. It can potentially also be abused and used for not so great things as well, which is obviously where the Microsoft privacy principles come into play. So we've been through a load of slides. So I basically said that now we're going to dive in and see how to use this stuff in real life. And where I'm going to take my examples from are the new role-based certifications that Microsoft have brought in. So, I mean, if you come here for the first time and you're just not up to play with AI at all, you might be sitting there thinking, oh, so now you're talking about taking an exam in AI. Don't let that put you off. I mean, if you don't want to take the exam at all, you can just follow through the examples and the documentation online and just get up to play, if you like, with what's going on. So there's quite a lot of these this one's called AI 900, Artificial Intelligence 900. And lots of the Microsoft certifications with that 900 number are basic entry-level exams. So don't let the 900 put you off. It is entry level. I don't know where they got the numbering from, because the next one up to that is called AI 100, and that's kind of builds on the information in the AI fundamentals. And there's another one there for Azure fundamentals, which is kind of good to get your knowledge up just about Azure in general. So there's a couple of links here to GitHub, where you'll actually find additional material that you can kind of go over. But let's jump over now and go into the Azure portal and the Microsoft Learn documentation and just see what is available here. So here we're looking at the AI 900 Microsoft Azure fundamentals. And even if you're looking for something else, you can hit the roles button, and there's a whole load of role-based certifications coming into play here. We can see AI engineer, which is what we're looking at here on that pathway. And if you were to click on that, you'll see a lot of basically what we call learning pathways that will take you into exploring things like the cognitive vision services, like the natural language processing and other things that are associated with AI. And these are all part of basically working towards that, any of those exams, or just going through this material to get to know, for example, how to build hubs or speech services, language services, or whatever. So that's actually quite interesting. Those role-based qualifications have only kind of come in over the last year or so and are replacing other Microsoft exams. But let's actually dive in to one of those pathways and see how you can get started. So here I've actually jumped into the analyze images with computer vision. And all of these pathways in the basic offering take the same kind of approach. You'll see here there's five exercises to go through, and the third one says takes 20 minutes, and the other ones are like literally quite trivial. So that's the one we're going to look at. We're actually going to dive into there. And this actually shows us how to get a free Azure subscription. Now, obviously, you're using cloud-based AI in the Azure cloud, so you are going to need access to an Azure subscription. Sorry, just getting a quick drink of water there. But you can actually get access to a subscription for free. Now, you will have to put in a credit card. The credit card is used purely to validate that you are a person, an individual, and that we haven't seen this credit card before. Now, there's a setting inside the Azure portal which caps the spending. Now, it's not spending money that you personally are going to spend. There's $100 spending limit on that service. Once that spending limit is reached, you basically can't surpass it. You can only surpass it if you take some sort of action and go into the portal and change your billing model. So although you're using a credit card, it's not some sort of trick to get you to spend money and next month it's going to bill you hundreds of dollars. You will not be billed at all unless you change that setting. And even after this $100 expires, there is still a lot of free services that you can use. And some of these AI services are free. There's still a lot of services you can use for free for up to 12 months. So if you've got access to something like an MSDN subscription or that, obviously this doesn't apply. If you don't have access to any Azure resources, dive in, get yourself a free subscription and play with this. So what we're going to do is this is going to take you through setting up some what we call notebooks. And those notebooks are going to have code in already. I'll actually dive over and show you one of the notebooks that we'll look at very shortly. So the notebooks have got code in them. Now, you do not have to understand this code at all. All you're going to do is basically replace certain attributes with code of your own. You'll see here, I've replaced a key and I've replaced a URL. And that's literally all you're going to have to do. You're not going to have to make changes to this code. You're not going to have to modify it in any way. There's no kind of instructions to modify anything. It's purely here to help you explore the cognitive services that are available. So I'm just going to jump back over to, and I'm not going to go through this step by step. I'm going to very quickly go through what you're going to do. You go over to this thing called ML.Azure, which is basically the Azure Machine Learning Studio. The next session after me is probably going to show that in a lot more detail and talk about machine learning. So I'll leave that for later. But you'll hop over to that studio and then you will create something called a machine learning studio resource and then link up to it. Now, once you've linked up to it, this machine learning studio, but once you've linked up with it, what you will essentially see is you'll create a blank notebook. I've called it get files here. It's basically going to run a line of Python code. And the only code that you have to touch is this line here. And you'll copy and paste that from an existing exercise. So if we come down, we'll see here, all those instructions that I've just said are listed out here. And then it basically says, copy this line of code and paste it into the first cell on the notebook. Now, I've already run this because it does take a little bit of time to actually run. But all that line of code does is it will go away to GitHub and it will download to this resource a whole heap of notebooks. And here they are here. So here's all the notebooks. And we can see, obviously, by the names, kind of what they do. Analyze images, detect objects, face API, text analytics. And we obviously haven't got time to go through all of these, but I definitely encourage you to get to this point and explore how you go about doing this. So let's just have a look at this one, which is the face API. So how are we going to, what are we going to do here? And they'll all kind of follow the same pattern. So I said that I pasted in a key and I pasted in a URL. So how did I get those two things? Well, what I did was I went to the Azure portal over here and I went to create a resource. So I've actually already done this, but I'm just going to walk through with you to explain. So cognitive service, like I said, that's a suite of applications. So you've got a choice. You can either create an object of cognitive services, and with that object, you will get access to like literally everything. It's like the face API, the image API, literally everything. And that's what I've done here. Now, you do have another option. What you could do, instead of creating a the top level cognitive service object, you could actually just create, like, say, a face API object, which is like getting pretty specific, or you could create an image API object. So the choice is yours. Essentially, the main difference is with the top level cognitive service object, you can obviously use the same key, which we're going to see in a minute, to access any of the subclasses. The main advantage there is you'll be billed as a whole, or your subscription will be billed as a whole. Whereas if you maybe want to do a separate face API and just be billed separately for the face recognition stuff, you can do that. So the choice is yours. But at this stage of the game, it doesn't really matter what you do. I've created a cognitive services account, and I've just called it generic there. So that's already been set up. I set that up previously, and I'm just going to hop in to that object. And we can see there's some quick start tutorials there, which you can go through in your own time. But the piece of information that we're specifically looking for here is the keys and endpoints. So I'm just going to show the keys. Obviously, these are GUIDs. These are specific to you. Clearly, you can see this online. This will obviously be gone in the next 15 minutes or so. But the piece of information you're going to need is one of those two keys and the endpoint. And obviously, when I created this, I had to choose a region, and I chose Australia East, which obviously Brisbane is in. So I picked that endpoint and a key, and I go over to my notebook and I simply paste it in there. Now, I've already run that cell. These cells are not going to take long to run at all. And that's basically just gone away and verified that, yeah, these keys are valid, the endpoint's valid, and you can use that. So we just go through, and just some things are happening behind the scenes. It's pulling in that API to this particular service that I've got here. It's not something that we particularly need to worry about. And then it actually shows you the code that could be used to basically identify these individuals. So I obviously have previously run this. I'll just run it again now. And we can see it's identified the faces of individuals here. And let's give us some more information there. No, it hasn't in that example. I think it will in the one below. It's this one's analyzing facial attributes. And these GUIDs would obviously come back if you were accessing this programmatically. Obviously, in looking at this, it doesn't make much sense to have them there. but has obviously identified an adult and a child. And over here, it's identified that anger, no; contempt, no; happiness, 1. So it's got giving these attributes a score out of 1. So here it's basically saying it's supremely confident that this person is looking happy. Most of the time, you probably won't see a score of exactly 1. It'll probably be maybe very close to 1, but maybe not quite 1. And this is code that will, which you can use yourself if you want, or you can just go through these notebooks and upload people's faces, or your own face, or whatever. So that's that. Now, those images were already pre-loaded for us, but let's go over here and have a look at the image classification one. Is it image analysis? So this one is very similar, but this is actually going to take us over to again, I've already gone through this myself, but somewhere in these instructions, it's going to take us over to this custom vision portal. And what I've done here is built myself a very quick no-code application to identify fruit. And all these images are downloadable through what I've just showed you. So how I've done this is I've set up basically a new service, and then I've added images over here. And I'll just add some of these images again, just to show you what happens. So there you go. I've added 4 oranges, and I'm going to tag those. Now, I've actually already tagged these images as oranges, but I'll tag them again as orange too. Obviously, you wouldn't do that in real life. This is just for demonstration purposes. And those objects are uploaded there. We click done, and we can obviously upload more and more images of different things. And we'll see there that I've actually uploaded 15 versions of apples, 15 bananas, 15 oranges, and I've tagged something just orange too, which is probably irrelevant. Now, after they're all loaded up and tagged, I can come up here and hit the train button, and that will basically, in the background, go away and train the ML model that's sitting behind the scenes here, and compare the apples and oranges and banana photos. And then we can actually do a quick test. So if we come in here, now I haven't actually got, let me very quickly, because I think we're nearly out of time, look for, maybe in here, image classification. There's a URL of an apple somewhere here where we can test it with. Okay, so here is a URL of basically an apple. So I'll copy that, come back over here. I'll paste that URL in. Hit it, and obviously it's showing us the image, which is an apple, and it's going away and thinking about what it is. And so it's obviously said it's an apple. It's got 99.8% accuracy that's an apple, which clearly you can see it is. But, there's a 0.1% chance, of a very slim chance, that it could potentially be an orange. So if you were looking at this programmatically, you'd obviously decide straight away, yep, that's an apple. And so that's really kind of a way you can get started with these cognitive services. And just playing with things like this will get you to, understand kind of what's going on. And even if you're a novice, you don't touch computers at all, you're just interested in AI, you could start uploading, images of your friends, images of people, your children, whatever, and experiment like that. Because I guess going forward, AI is going to become more and more and more a part of our lives, whether we recognize it as AI or not. So, knowing how this stuff works behind the scenes, like I say, even if you're not a computer person, it's just kind of relevant to how you work in real life anyway. And these notebooks over here, I mean, maybe they're a bit too advanced for some children not to work through, but if you've got like secondary school children or whatever, they can go through these examples. And like I say, all I have to really do is set up a cognitive services object or a face API or whatever, and then paste in the keys. And that's literally all there is to it. And then you can basically learn off the code what's going on. Now, it is obviously Python code. It's not too hard there. We can see it. It tells you there. You've got to paste in the project ID, the key, and the endpoint. And so basically what we've just seen there with the apples and oranges, I could go back over to that portal, grab the prediction keys and things like that, paste them in over here, and use the model that's been generated behind the scenes through this code here in the notebook, basically. So they all go through like that. There's a bot service down there, slightly more advanced notebook, language understanding, Lewis, speech, and the like. So rather than me making my own examples up there, I thought it was probably better to just like dive in, get something that's easily accessible. So like literally every single one of you, wherever you are watching this, and you can dive in right now and start playing with this. So I think we're nearly kind of out of time. So I'll just recap there what I've said about the next steps. These AI 900 exams, they're basically fundamental exams. There's quite a lot of them around. This one's for the AI fundamentals. There's one for like data platform fundamentals, Azure fundamentals. And like I say, even if you're not going to do the exams, the resources are really good to ease you into whatever it is you want to learn, whether it's AI or Azure or whatever. So there's some additional resources there, which will take you through to GitHub projects, similar kind of concepts to the notebook sort of thing that we've just seen, but code that obviously other people have wrote that showcases these basic cognitive services and how they work behind the scenes, and basically just lets you play with them. So we are now coming up, I think we might be a couple of minutes over the 45-minute mark. So it's a bit of a whirlwind tour of cognitive services. I hope you've got something out of that, whether you come to this as a beginner or even as a fully fledged AI expert, because obviously there's additional resources you can learn behind the scenes as you progress on your journey, whatever that journey is. So I'd like to thank you for listening, and I'm happy to take any questions or just talk over some of the stuff that we've seen here today.
Well, Martin, that was amazing. Thank you a lot for presenting Azure Cognitive Services. I do have one question, actually, for the attendees that are looking at the live stream, or they are going to look at the video in the YouTube channel. Is that what about? So you told us that pretty much starting for free is a key benefit of this Azure Cognitive Services. So, from your own experience, so. Do you enjoy starting? Do you find it easy actually starting with Azure Cognitive Services?
I actually did. So from my own perspective, I guess we know each other, but just for the audience, my background is in data, transactional data, SQL Server, that kind of thing. Now, these cognitive services, I think they debuted about 2016, about 4 years ago. And initially, I seen people talking about them, and I just got the impression that they were quite complicated and that they had a bit of a steep learning curve. And it took me about a year or two before I actually decided to sit down and play with them. And then I don't know. I just looked at them and went, yeah. I don't know why I had that mindset. Why I thought they were so difficult. Because they're actually not. And then I seen that Microsoft have released these learn modules, and I wish they were around when I was playing with the thing, because I was kind of just learning off of the people I know in the community, seeing basically things like SQL Saturdays, which if no one knows, they're just free one-day events on a Saturday that talk not just about SQL, just talk about, well, they were originally just SQL, but now they've sprawled kind of into the Microsoft data platform, AI, ML sort of space in general. But yeah, I was just totally surprised and flabbergasted how I'd come to the decision that these were obviously at a difficult entry level, because they absolutely don't. Now, clearly, you can go on and start writing really advanced Python code and R code and whatever, and get into deep learning and do some really, really advanced things. But that wasn't what this presentation was about. This presentation was just about getting started the easiest and quickest way you can. So to answer your question kind of directly, I don't think they have got much of a learning curve at all. In fact, probably the most advanced thing you're going to have to do is set up that free account. And once you've set it up,
that's a good point.
You go.
Yeah, that's a good point.
Yeah.
Okay. So actually, if you want to contact Martin, actually, there you have the email address. Feel free to send him an email or information. We also have a question from Gary. He's asking if we can share the links in the chat. I think we'll follow up with you, Martin, to get those links, and we'll share them.
What link are we talking? Are we talking about those links I put up for?
Yeah, I think he's talking about the links in your last slide.
Yeah. Okay. Stand by. I will do some copy and pasting right now.
And if you can share it directly in comments, just share it in private chat and we'll share it for you.
Right. Okay.
Yeah.
So
cool. So Martin, thanks a lot for getting involved with the Queensland community. It's great to have you here, actually living in Queensland now.
Yeah, thanks a lot. I'll tell you what was really interesting before. The lady who spoke during the intro and told us about the Queensland AI group, which obviously in addition to the group that you're running here. And it sounds like they've got some fantastic resources for the whole community, from basically primary school children right up to people who are just looking to enhance their knowledge.
Yeah, definitely. Okay, Martin, so I need to say goodbye, but we'll keep in touch. I'll see you around in the physical events and the meetup groups. Take care.
Thank you.
Thanks a lot. Okay, next up, guys. So after this amazing presentation from Martin about Azure Cognitive Services, so next up we have Akansha, and she's going to be talking about actually a machine learning studio. But we'll kick off the presentation in about two minutes. So stay tuned, and we'll go for a really, really short break. Hi, good morning, Akansha. How are you?
Good, good, good. Good morning. How are we?
Good, good, actually. So it's great to have you here. And I think we're moving actually to that area that is not morning anymore. I think you're based in Sydney, right?
Melbourne. So yeah, down
Melbourne,
south.
okay.
I'm an hour ahead. I mean, it's still morning. It hasn't hit 12 o'clock
It's
yet.
still
But
morning. It
also,
seems to be
I'm
like almost lunchtime, right?
yeah, but then again, I'm also known to be saying good morning at 7 p.m. So it's a facade. Everything goes.
Okay, it's great. It's great to have you here. Actually, you have an awesome presentation lineup about Azure Machine Learning Studio. But before we jump into the presentation, a little bit for the attendees, actually, so they know you a little bit more. So, how do you get started actually in machine learning? Yeah.
I ended up into a job which was a data science job as a graduate, and then I was like, right, okay, data science, I think that involves machine learning. I just kind of started testing things here and there. But mostly I think it was just the case that I'm a data scientist now and I think I should know something around this. So started mucking around with things and somehow I've ended up into this whole world of doing all these fun little things with machine learning and artificial intelligence now. Basically, I kind of fell into it is the answer.
Okay, and I believe you work actually for Telstra Purple, right?
Yep, Telstra Purple.
Okay. Oh, that's amazing. So I think you and our next speaker, Josri, both of them, do you work in the same team or different teams?
We actually worked in the same team from until June, like for the whole start of the year. We were on the same team. He's absolutely lovely. And his presentation is amazing because he taught me everything in that presentation while we worked together.
Oh, okay, that's cool. Okay, cool. I don't want to take more of your time. So what I'll do, pretty much I'll jump off from the stream and I'll leave it with you. Enjoy.
Perfect. Okay, cool. Everyone, welcome. I've got the comments going on the side. So if you have anything to say as I go along, please feel free to shoot them. I will try and keep an eye as much as I can. So yeah, my name is Akansha Malik, and I'm going to be doing a talk on Azure Machine Learning Studio and about zero code solutions. So it's not going to be a very in-depth codey technical talk. It's going to be a very high level and kind of a how do we do things without coding in this day and age. So without further ado, let me move my slides to the next one and talk a little bit about me. It's my favorite topic, but that's the most Irish photo I can find of myself. So for those of you who don't know me and we're trying to figure out what the accent is, it's a weird mix of different things now, but it's predominantly an Irish accent. As I studied in Ireland and I lived there until I graduated college, and I studied financial maths and actuarial science. And as I was saying earlier, I moved to Melbourne and I found myself in a data science role. And that's kind of how this whole new world started for me, where I was like, okay, I'm doing data science. Data science, I think, has something to do with AI. So I started looking into AI, found it was a lot bigger of a world than I expected it to be, and then started drilling into different things. Machine learning was something I kind of was just fascinated by. I heard little bits about it, tried a few different things, and here I am now doing presentations on the things I've learned. It's just the easiest way for me to kind of continuously learn is by forcing myself to do presentations on the things I'm learning. So that's kind of why I'm here. And just as an FYI, I am in Melbourne and the pollen count is ridiculous. So if I start sniffling halfway through, it's the hay fever and not corona or anything like that. But yeah, please bear with me. And bar that, let's actually go straight into our demo. Sorry, not our demo, the rest of the introduction of the slides. So today's agenda. My agenda today is just essentially, I want to be able to create a model with absolutely no code involved, and how that is enabling, so the whole product of Azure Machine Learning, how it's enabling people with various skill levels, whether you're someone who has no coding abilities, great, come along, you should be able to do AI and machine learning. Or whether it's someone who's a data scientist and has done PhDs upon PhDs in the field, and how it's enabling them to actually make the most of their time and be really efficient with how they're building their models. So that's kind of what the aim for today is. If you leave the next 40 minutes with an idea of, hey, if I wanted to, I kind of know how I could go about creating a model, I'll be really, really happy. And if you actually do go create a model, please let me know. It makes me really happy. So just talking about AI in the market in general, it's everywhere, right? All the buzzwords, AI systems, the object detections that are happening, bots, knowledge mining. If you talk to someone who is like a CIO or a CFO or anyone in the C-suite, they're obsessed with the idea of it. They're like, yes, we want our company to have AI because it's cool and future thinking. But no one really kind of grasps exactly what it is. And that's where that little shortfall falls through. So it's important that it's really, really big in the market, but what does it actually mean and how does it work to make sure you have that distinguishing features in there? Everyone wants it, but there's a lot of challenges with adoption of AI. So all these businesses and all these business people are like, yes, bring it to us, but then they don't realize how hard it can be. Or even if they do adopt it, then they kind of get stalled with, okay, they've maybe started using AI, but then they don't know how to make the most of it. And it's kind of predominantly a challenge based on the people. It's really hard to find data scientists and the people who can actually do the work that you need them to do. And that kind of stems as well from the fact that it's such a diverse topic, data science and AI and ML. If you look at the skills and stuff that you need, if I look at my skills, I usually use Python, but there's also people I know who only use R. That's immediately just a split in the fork of what the skill level is. If you've hired someone who's only used Python and built all of your procedures with Python, you can't hire someone that only has R skills to come in and help you out. You need to find another Python person. So as much as everyone wants to be a data scientist these days, there's still a really big shortage of the people that we need to be able to do the work. And then it goes into the processes. Processes can be so vast and so big. Setting up a environment for data science or any data projects can take time. It's just really menial. I mean, I've been on client projects before where it was a 2-week project, and I think it took me a week to actually just get access and set up on the whole environment. So process can be a little bit tough, and that's an adoption problem, because if you can't scale up really quickly, people lose interest, businesses lose interest. I'm like, why will they be willing to spend money for you to just set things up and not see any actual results? And then the technology itself. It's scary the amount of data that is needed at times to do these things, but then also that means at the same time, you need to be able to make sure that your data is secure. All your models are secure, everything with the architecture, security, and being able to scale it. So if you're an individual person, right? I've created machine learning models on products that are just like on data that's 50,000 rows that sits on an Excel sheet somewhere on my laptop. That's great. But when you're looking at a big enterprise business, you need to be able to scale that across the business, which could be millions and millions of rows or terabytes of data. How does your architecture manage that? Where is that going to be stored? Is that going to be safe? These are all really, really big problems that the industry is facing at the moment. So with that in mind, let's talk about democratic. I can never say this word, and it's like my favorite word across the whole thing. So democratizing AI. And this is where Azure Machine Learning Studio has come in a little bit. There's so many challenges to adoption and stuff that the people problem. We need people who really have specific skills. Creating products like this, which are zero code, it removes that problem because you don't necessarily have to have all these really specialized skills anymore. It's kind of for everyone. And that's the whole kind of ideal world that we're aiming towards, is the fact that everyone should be able to use it. I have a ton of data that exists in the world. I can leverage it at some level just because I have a few skills that I've developed. But everybody across the world, 7 billion people, have data associated to them. And it shouldn't be gatekept, that ability to use it and leverage it, just behind people who've been able to do maths or have the time to go do study and create models for their things. It just makes it easier and involves everyone in the conversation. So that's why I love talking about all these zero code solutions and stuff, just because it brings everyone into the conversation. So with that, let's actually look at Azure Machine Learning Studio as a whole. Who does it offer to? What does it offer? So they've got 3 main products within the studio, and I'll explain who it works the best for. So you could have someone who is absolutely no code and all the way to a code first level, and someone with no machine learning understanding at all to someone who's a machine learning expert. And notebooks and SDKs are a product that it offers. And those are for people predominantly who know exactly what they want to do. They know how to code. They know what libraries they want. They know what their data is. They can start going in, doing all their analysis, transformations, and pipelines, and testing and training stuff, and actually create their own models really, really specifically. So those exist, and those are there for those people who know what they want to do with the notebooks. But then on the complete opposite end of that spectrum, we also have AutoML, which is another feature of Azure Machine Learning Studio. And that's kind of for people who have absolutely no coding abilities and don't necessarily want to spend time trying to learn how to code because they have other things to be doing. And for someone who doesn't necessarily understand machine learning or wants to spend time figuring out what is a training pipeline or what's a testing pipeline, they just know that they have data in front of them that can be smarter and it can be leveraged, and that's the product. But it's not just for those people. It's also for the data scientists who use notebooks. It just reduces the amount of time that you have to go individually figuring out what's the best parameter or what's the best model for you. If you just run an AutoML, it'll tell you, hey, these are the best kind of models I found. And then you can go take those away and actually really, really precision test those and make the accuracy a lot better on those. And somewhere in the middle of the two is the last product, which is Designer. And Designer is a drag and drop visual interface that they've created for machine learning. So there's no code involved because it's all drag and drop, but there is a lot more machine learning understanding that's needed for Designer, because you do still need to be able to understand how a machine learning pipeline looks. That you have your data, you need to clean your data, then you need to do your splits of training and testing data, actually put in the correct model that you want to assign to it. Sorry about that pop-up, thought I'd X'd out everything. And how to actually go train the model afterwards and what do you do with it. So there is a lot more machine learning expertise involved with Designer. So it's again that little midway for the people of, hey, you don't have to code, but you know what happens in machine learning, off you go. If you don't want any of that, there's AutoML, and then there's notebooks, which again are just for the classic scenario that you're used to hearing about data scientists who know exactly what they want to do with Python and their libraries. So today we're going to be focusing on Designer and AutoML as the no-code products that we have. So with that, what's my data? What are we going to be using and understanding? So these are kind of classic examples that exist in the market, or if you listen to anyone do demonstrations, it's just because the data is really, really big and really readily available, and it's easy to understand. So I've got a New York taxi data set. So if the world goes back to normal once these vaccines actually work, I might go to New York and I might want to go get a taxi. And America is just filled with all these tipping systems. I'm like, how much should I be tipping? So what I'm going to be using the New York taxi data set is to be able to predict how much you should be tipping based on fares and other details about a taxi ride. And also, we've also got another data set, which is the used car database. And so ton of data, different parts of the cars. Okay, if it's a four-wheel car, if it's got X amount of miles on it, all these different bits, how much should that car cost me? What is the fair value of that car? So those are my two data sets, and that's the machine learning I'm going to be doing on them. And with that, let's jump into a demo. So what we're going to go through is exactly how you would set up those two machine learning pipelines without using any code in a fairly short amount of time and actually be able to use those models that you have created. But also, this is just a very high-level overview so that you kind of walk away with an idea of how you would do it, not necessarily exactly the step-by-step version. So whenever you're trying to do anything with Azure, at least your first place, your favorite place that should be is your portal and home. And to find your machine learning resources, you can search for machine learning. It'll pop straight up for me because I search it all the time. And once you do, you just need to create your workspace. And they've made this really, really straightforward now. All you really need is subscription. And after that, you can create a new resource group from the setup page itself. I'm just going to call this test for now. And give it a workspace name. SAM, let's call it that. And what this does is automatically it creates a storage account, a key vault, application insights alongside your machine learning resources. You can also create a container registry, but you don't necessarily need one unless you're doing something specific. And that's it. Off you go. You just hit create at the end of this, and it'll create a machine learning workspace for you. And that workspace, let me just go back to a workspace, looks something like this. And as you can see, it's got all your details and stuff. Please don't steal my details. But all you see here is the Launch Studio, and this brings you to the homepage of Machine Learning Studio. So the reason Azure Machine Learning Studio was created was essentially to give people in data and data science a one-stop place to go to. So this essentially features everything you really need to do any data science work. So that's the whole premise of this, and you can do collaboration and a lot of stuff with the whole studio, but we won't dive into that today. And you can see there's the notebooks, AutoML, and the designer that I mentioned earlier. So when you think about data science or any machine learning problem anyway, there's two main things you need. You need a lot of data, and you need the actual machine to be able to do machine learning on. And all of that stuff is actually stored in one place. So you can go into your compute, and you can set up your computes from here, and you can manage them, turn them off, do whatever you'd like with them. From here, so there's a few different types, and I swear this is the most complicated it gets. There's compute instance, so this is whenever you're trying to do any machine-heavy tasks, this is the kind of computing power it'll use. And to create the new ones, they're made the actual workflow really straightforward in terms of you pick a region, and it'll only show you the ones that you can actually access in terms of if you've only got specific capacity available on your subscription, those are the only ones it'll show you. You pick whichever one you'd like. It automatically picks the basic one, kind of the standard go-to one that most people use. And you hit next, and you just give it a name. And that's essentially all you have to do. And the same goes for a cluster. If you were doing any kind of batch training and things like that, this is just multiple different machines clustered into one that can do your work a lot quicker. It's the exact, sorry, my mouse is going a bit crazy, but it's the exact same process in terms of setting up this as well. It'll only show you the ones that you can actually access and create based on your subscription restrictions that you might have. And the only other one is the inference clusters. These are the ones that are used to actually, so these are Kubernetes services is the easiest one to use. These are where if once you've deployed your model, this is how the power it'll use to actually maintain that as a live deployment. I swear that was the most complicated it was going to get. So that's the compute powers. And if you're confused about what one you need, or if you need to be creating all of them, don't worry, because when you actually start doing, and I'll show you this, when you actually start deploying your models, it'll actually tell you which one you need if you don't already have it created, and it'll guide you through the whole step process, not a problem. So those are your computes. So if you've got the machine sorted, we need data. You can connect whatever data store you'd like. You can connect it individually within your subscription. You can create them manually against different account keys and stuff, wherever you'd like. They're happy enough for you to bring your data from wherever. I'm just going to cancel that one here. Or if you wanted just a specific data set, you can actually create data sets from either a local file. If you've just got it sitting on your laptop, you can upload it directly here from web. If you know there's a link maybe on Kaggle or something that you want to use their data sets, you can import that directly within the studio itself. And open data sets. This is kind of my favorite thing on Azure Machine Learning Studio, just because if you're trying out the whole place for the first time, or you're trying to create a model, they've got all these data sets ready for you to use and implement into the product, and off you go. So I've basically pulled in the New York taxi data set. I don't know why it's kind of pushed into the corner a little bit, but let me just click into that so you can see. So this is the New York taxi data set, and you can literally call it whatever you'd like and pick the date range from what you want all your data. It's a really, really big data set. So just be a little bit careful. Maybe you only want a month of data for this to actually start training and testing out stuff. And that's it. Like that will basically create a data set for you. I'm just going to leave that there. And it looks something like this. So it creates a data set. It has all your details for it. And off you go, basically. It's like ready to use, and it'll pop up in different places. So we've now got our machines, and we've got our data connected up in different places. Let's actually create a model. So I mentioned AutoML, and AutoML, automated machine learning. I'm going to use this New York taxi data set, and I want to predict, like I said, I want to be able to predict what my tipping should be for a taxi trip around New York. So again, these are the data sets I've already created, but you can also create a data set again directly from here. So if you just wanted to dive straight into automated machine learning, you don't necessarily have to go through different steps beforehand. It actually guides you through the whole process. So you can connect from here, or like I've already got it, I'm just going to put that one through. So I've selected my data set, and it'll basically tell me, okay, great. These are just the back-end things of where do you want this to sit? What do we want to name this experiment? So every time you run a machine learning model or anything like that, it's called an experiment here. And everything under that experiment gets grouped into one place, and it stores it in that place. So you can create a new one, or you can select an existing one and pick a target column. this is what you want to be able to predict. So like I mentioned, there's a few bunch of things here, but what I want to be able to predict is the tip amount. So I'll select my target column. And again, select your compute cluster. So for automated machine learning, you need a cluster compute. And if you didn't know that, that's not a problem at all, because you can actually create a new compute directly from here. So I'll just pick the one that's already been created. Sorry, let's create a new one. Let's call this test. And that's the third step. And so what kind of a task do you want to do? So machine learning can have a different variations, right? So you've got your classic classification kind of a problem where you've got a bunch of data and you want to be able to group it into specific things, whether it's green or blue or red. That could be a problem you might have. But what I want to be able to do is predict exactly how much tip I should have based on a few different factors. So that's going to be a prediction of a specific number. So I'm going to choose regression. And you can choose additional configuration settings and featureization stuff. But again, if you don't want to, not a problem at all. And that's it. You just click finish. So in about 3 clicks, I've basically been able to connect my data, create a compute store, and then make it go do machine learning on top of it. And I had to do no other work to do alongside it. So if I click finish, it'll actually start running this job. I'm going to cancel because I've already run it. It takes about 30 minutes to do it. So I'll show you one that I ran this morning. So this was the experiment that I ran this morning. It took 40 minutes to run this one. And you can see that this was a specific run. And what it does is then it picks out the best model and it gives you a summary of it. So it's told me that extreme random trees or the standard scale wrapper are the best ones. It's got correlation metrics, all these different things. But again, if I'm not a data scientist, I might be a New Yorker just living and wanting to know these things. Or, I mean, if you're a New Yorker, you probably know how to tip your taxi drivers. But maybe you're like me, or a tourist going to New York and wanting to know. You don't care about the details, you just want to see exactly what it's created. So you can pick your algorithm, so it'll tell you this was the specific one. And then you can actually have a look at the explanation as to, okay, why is this the best? What's it actually doing? So to be able to predict a tip amount, the most important feature from the data is the total amount of your fare. I mean, that makes sense. Your tip makes up your total amount. The payment type apparently is really, really important according to this model that it's found it, and the fare amount. So if you've got $20 fare, the kind of payment it was, if you're putting it on the card, you might tip more. If you're paying in cash, you might be tipping less. So it is really important in terms of payment type. And then the total amount is a really big feature. So obviously, if you wanted to test different things, you could remove specific columns like total amount and run the model again. It takes that time out of you manually having to do this and just lets it run in the background while you can go do other things. So it saves you that kind of manual time-heavy parts of machine learning. Great, okay, cool. I'm happy enough with the model as it is. I can have a few looks at metrics. I can pop in, so this just becomes a kind of visualization chart where you can pop whatever kind of metrics you'd like. You'd be able to see them. You can see histograms. And other than that, I think that's kind of all you really want to be seeing on this page. But once you were like, yep, I'm happy with this as it is, I can click deploy. And what deploying does is now reads to the compute type, which is a Kubernetes service. And you can pick whichever one. And this will deploy this model ready for you to use as whatever you'd like. And what it gives you, let me show you what an endpoint looks like, is something like this. So for the taxi, it takes a little bit of time, but it'll give you a REST endpoint. So if you're a developer and you just wanted to be able to add a little bit smarts to your application that you've built, you can do that. Use your data set, pop it up into automated machine learning, and for the one click, you create a REST endpoint that you can then copy and actually connect to, and it can use away against your application with no issues at all. I've never used REST APIs or connected them with applications, but from my developer friends that I've talked to, they say it's fairly straightforward. I won't say much more about that, but that's kind of from the machine learning parts of it. It doesn't take a lot of time or effort for you to actually get that going on the back end for you to be able to actually use it in wherever you might want to. So yeah, consuming, it just gives you that REST endpoint ready to go. So that's automated machine learning. With no coding or no machine learning knowledge needed, in about 5 or 6 clicks, I think it takes altogether, and about 40 minutes of your time, you've got a ready to go machine learning model. and it costs fairly minimal. So these target computes and stuff there, I think they cost about 30 cents an hour. So if your model is only taking about 40 minutes to load or to train up and stuff, and then deploy, your actual computing cost has been about 30 cents so far. Granted, if you're keeping your Kubernetes service going a lot longer, that might be a different cost, ongoing cost. But to get that set up and going, it only costs you 30 cents. And you didn't need to have a really big machine. You didn't need to have a really up-to-date 2020 MacBook Pro or anything like that. You could do this from wherever you'd like because it's all based in the cloud. That's that whole point of the democratizing AI, where it's available and ready to use for everyone at low cost. So that's automated machine learning. And the other low-code kind of a feature that I mentioned was Designer. So what Designer looks like is, as I mentioned, a drag and drop feature. There's a few demo ones that you can use. I'll just try and I'll show you actually what it looks like to create a brand new pipeline. So let's call this, as usual for every single demo, let's just call it test. I'm just going to pray to the gods that this actually works out on its own and I don't have to go through too much of a pain. So any data set that you've already created and registered it as a data set originally, those will pop up here, ready to be used. Or they've also got sample data sets. So I'm going to pull in the automobiles price data. So this is the sample data that I mentioned in the start. This is going to be the secondhand cars and what they look like. So I've got this data set here. And what do I want to do with it? I don't know much what sits in here. What does it look like? So I can actually have a quick look at what the data set looks like. And this is just an output of, these are the different columns it has, and it actually gives a histogram of each of the columns. So we've got the make of the cars, the normalized losses. I'm not too sure what that column is off the top of my head. I'm like, okay, maybe I don't want to see that column when I actually run this model. The fuel type of the car, I'm like, yep, that seems kind of important to be able to guess how much the car is worth. Number of doors, the body style, so many different columns and details about every single car in this range. And then at the end is the price. And that's the price, is the current price that they've got mentioned for that car. So what I want to be able to do is, based on all these 25 different columns, be able to predict what the price should be. That will be my machine learning model here today. So I've got that. And the next thing I maybe want to do is actually, like I said, I saw that normalized losses and I didn't really like, I'm like, I don't know what that column is. I'm going to remove that column. So we can do that with the drag and drop tag. So we can edit our metadata. Let's pop that there, connect it to this. And this basically changes and edits your columns. So I want to include, actually I want to include all my columns. Let's include them. And then I just want to exclude one of them. And I want to exclude a specific column. And that wants to be the normalized losses. I don't think that's going to be important into my model. So I'll remove that one. And once I've done that, the next step, as every data scientist will tell you, is cleaning your data. Cleaning your data is really, really important, as you only want to give the machine kind of what the bare minimums of what it actually needs to be able to use. You don't want to confuse it with extra data or incorrect data necessarily. So let's do clean missing. I want to be able to clean my missing data. Let's pull that in. Excuse me. And how do I want to do it? So clean my data across. I want to actually, all my columns, I want to be able to do that on. And just for the sake of showing you all, please don't actually ever delete any data columns or rows like this, but just for the basis of it, I just want to replace, let's say I can remove my entire row if there's a missing value somewhere, or I can replace with the mean, median, mode. There's a few different options that they've given you. Just for now, I'm just going to remove the entire row, please. I mean, I feel like user might be watching. I swear I don't actually do this at work. I will never remove data that sits in live data. So once I've cleaned my data, I'm kind of like, yep, my model, I mean, the data set's pretty clean. I'm okay with this. It's ready to go. And again, machine learning, the next step is usually going to be splitting your data so that you can actually train it and then test it. It's kind of like teaching kids, right? So I mean, if you're in primary school, you're given a lot of stuff, you learn it, and then there's a test at the end of the day where you go test how much of it you've learned. Same principle applies here. So what we're going to do is split our data. Oops, sorry. Let's push that down here, connect that there. And maybe I want to split it 70%. So I'll give the machine 70% of my data to learn from, and then the rest of the 30%, I'll actually test them on it of how well did you do? Like, did you figure it out? How much should a car be priced at? We'll see. So 70% is all I want to split it to. Let's move this down a bit. And then I'd like to actually be able to train my model. If I can find my train model, there we go. I want to train it. So as you can see, the split data has two ends coming out of it. So the first one's going to be the 70%. That's the one I want to train. I say as it's got an error. I don't know why it's doing that for me. Let's just push that in again. Why are there errors? Oh, sorry, just wanted in there one. Okay, cool, that'll do. Right, so training my model, it kind of as, okay, I'll just delete this so I can show you that bit again. Oh God, okay. Yeah. When you try and drag it, it actually tells you what little holder it wants you to put it against. So it wants you to put it there specifically. So this is the data that you're sending to it. But when you're training a model, you actually need an algorithm to train it with. So that's what the first little bit is going to be. So you can choose specific different ones. It's got a bunch of different models you can use. So let me show you the different level, all the different ones it has. It's got a bunch of machine learning algorithms that you can use. But I mean, there's different things that you can always use. I'm just going to pull out the basic kind of a linear regression. Let's just start with that one. I'll pop that in. And that one's going to connect to here. And here, I want to actually tell it what model I want to be able to train it against. So I want to select a specific column, and that's going to be, as I said, we want to know what the price is when I predict it. So that's ready to go in training. Once I've trained the model, I need to actually score that model. And that scoring, what that essentially means is like, let me put it in. Okay, great. This is training. You've learned all that. And now let's test you against what it should be. So this is the testing data we pulled in and the trained data model. It's now figuring all these things out. So it'll score it, how well it's actually doing. Once it's on that, we'll give it an evaluation. So I want a full evaluation of the model of how well it did. So I can go into either of these. So we'll just pop it here. And that's basically it. I don't know why those things have popped up right now, but oh, okay, they're kind of disappearing on their own. That's a whole pipeline ready to go for you. And this applies to even really, really in-depth data scientists with PhDs who know exactly what they want to do. Because what this now means for you is I can just use drag and drops to really quickly test out maybe 5 or 6 different algorithms against my data on my 7% data and be like, okay, this is going to be the best one. And then actually go and start using notebooks to really dig deep into really parameterizing and tuning that model out to be the highest accuracy it can be. So once I'm there, all I have to do is hit submit, and this will go and start running it. So what I created one this morning, so I'll show you what that looks like. Once you hit submit, it shows you exactly what it did. It'll tell you all the steps have been completed. And you should be able to see the metrics. Okay, I'll pull those up in a different place and show you the actual how well it's done. But from here, you can, again, like I mentioned, the inference pipelines. So with the automated ML, we deployed our model to create an endpoint. It's the same step here. You can create a real-time inference pipeline. And what this does is it'll create, again, like we talked about, that endpoint ready for you to use as a REST API that you can connect to, and it stays real time. So whenever someone on your app is using that data or wants to get a prediction, automatically it'll run the model and give you a prediction. So once you deploy it, this is kind of what it looks like. So these models have then been registered in a model list. You can also find all your experiments in one place. So I've tried a few different things around here. They're all ready and waiting for me. And then the endpoints, like I mentioned. So the designer cars created that endpoint. And once it loads, it'll show me the exact same kind of REST API ready for you to use. and implement. You can actually, for anything using Designer at the moment, so they've implemented this functionality, they haven't done it for automated ML yet, but you can actually test exactly what this would look like on your app. So if you, on your app, have gone in and put all these details in of what the fuel type is, the car, it's a convertible, random details, you can ask it to actually test what your model would predict for this. So the price of the car was 13,000 and it's gone and predicted 22,000. Like, it's a little way off. But what if your machine learning model is telling you that this car is worth 22,000 and it's actually only being sold to you for 13,000? That's a bargain, but don't take the word for it yet. Obviously, go do a bit more detailed understanding of exactly how it works and just check all the details that you need to. But that's just a really kind of quick way of showing you exactly what it does in terms of when you reach for the web service and the API system. So that's Designer. It took a little bit more understanding of how machine learnings work, because you need to choose what kind of model you want to use, what algorithms you want to do, what your splits should be. So it's a lot more customizable in that sense than your automated ML. It's still really, really quick and fairly easy to set up. So that pipeline takes about 15, 20 minutes to actually run through and do all the training on. So let me just jump back into my slides. So I'm hoping you can see that now. Yep. So as a recap, my agenda for today was to show you a few features of using absolutely no code to create machine learning pipelines, which I think I did. I'm hoping someone somewhere out there got something out of this in terms of, hey, okay, cool, that looks pretty okay. I should be able to go do this if I wanted to. And just how easily in that one scenario, one studio setup, it enables everyone. So whether you're a data scientist, whether you're a doctor, just wanting to you have a bunch of data, you want to see if there's something you can predict out of it. Doesn't matter who you are, it's all in one place, ready for you to go, and supports everyone's capabilities and really guides you through quickly enough, but also it's not overwhelmingly like basic levels. But if you've forgotten to set up your compute, it's ready, it's already there, it's fine. You can create it when you're actually setting up your pipelines. It's all been built for everyone in mind, essentially. So that is my presentation. Thank you all for listening. I'm happy to take any questions that you might have. I actually have absolutely no idea if I've gone over or under my time at this stage. I can't see my timer anymore.
Hey, Akansha, what an amazing presentation. Thanks a lot, actually. I think this complements perfectly actually our previous presentation from Martin, because actually what you're showing here actually is pretty much breaking down a little bit that machine learning complexity and allow people and businesses to start using machine learning easily, actually.
Yeah, I mean, as a business, you're not necessarily then reliant on the 2 data scientists you might have on your team, which have 100 different things they need to do, but you can actually just go do it yourself if you had to. And then get them to help you out with maybe really making it accurate and actually tuning it up a lot more. Just removes a lot of barriers overall, I think.
Yeah, I do have one question actually for you. What were some of the challenges that you found when learning about machine learning Designer?
Okay, honestly, it's the drag and drop. So I mean, it's still they're still working on it. It's the drag and drops. They've got a lot better now, especially I think I showed it where if you're trying to drag something, it tells you what little bracket to put it onto. That didn't exist at the start. So I remember when I was doing it, I was trying to drag things in and it just wouldn't work. It wouldn't connect to different things. And I'm like, but this is where it's meant to go. I don't know where else to put this. It's the other one that I had to put it on. Okay. There's a few things like that, but they're making a lot more improvements like that where they just highlight which one where you need to go. Or yeah, like the thing with Designer is you do need to know exactly what you want to do. So if you want to do linear regression, you'll know where it is to find. But then what if you don't even know if that's a feature that's available? Like, I mean, they've got all these different algorithms. You need to actually sit down and go through them a little bit. So that can be a bit daunting for some people.
Yeah, and that's a good point, actually, because I did have the opportunity to use Machine Learning Designer or previously Studio. And actually, the order of the components needs to follow a logical order, actually.
Yeah.
There is a specific order that you want to follow. And that's a good thing, actually, right?
Yeah.
And definitely that maybe requires a little bit of a learning curve, but still pretty much you can. I think I found you can. Is what I did actually drag and drop and see. Okay, I cannot actually connect that data set to this. I need to do this first, right?
It's a little bit of testing and trying, but it's kind of fun. I'm not gonna. I mean, it kind of brings you back to like the school stuff where you're like, oh, let's test all this stuff out, see where it goes.
Yeah, definitely. Okay, for the attendees in the stream, if you have any questions, feel free to put them in the comments in YouTube. What's the best way for the attendees to contact you? Is your Twitter handle or?
Yeah, Twitter is definitely the easiest in terms. I mean, LinkedIn just gets spammed with recruiters all the time, even though I've told them not to. But I mean, if you reach out on LinkedIn, 90% of the time, I won't actually even see it. It just gets really bogged down. Twitter, definitely reach out on Twitter. I'm usually very active on Twitter. Yeah.
Okay, that's amazing. One more question, actually. What about working with large volumes of information? Will machine learning designer be able to work with that?
I haven't tested that specifically, but it'll have no issues doing it because, again, the power it needs sits in the compute. And again, you can scale those up and down as big or small as you need those clusters to be. So it'll handle it. That's not an issue. It might take a little bit longer than you're used to for a smaller data set, but you can bump up your clusters and just add a few more machines against it. It'll do it really quickly. So then again, it comes down to how quickly do you want it and how much of a cost you want, but it shouldn't have any issues.
Yeah. One of your previous slides, you highlighted some of the challenges about adopting machine learning. One of those challenges, pretty much, you need to have the skills. You need to have people. What are your thoughts on where the Australian market stands right now within having skills available in the market? Do you believe that we already have many skills? We are short on skills or experts?
I feel like everyone would have a different point of view on this question. It kind of is like one of those consulting answers of, well, it depends.
No, we want your point of view, actually.
Exactly. I think there's still demand. Like there'll constantly be a demand, especially in the current era we're living in with the pandemic. I mean, it's an unfortunate situation to be in, but people just don't have the budgets to pay for people to be doing the work. And AI and machine learning can really help in that. It'll automate a lot of more tasks for you. Like it's a booming industry, especially now moving forward. And it's not necessarily that jobs are being taken away. They're just being replaced with a different type of job, which is creating machine learning models that can help reduce effort for businesses. And so I think the market is getting a lot bigger and it's getting a lot more notice than it did maybe even a couple of years ago. And as many people are entering into it, it's one of those things. It's a double-sided sword, right? I mean, it's like, it's machine learning is really easy to do now with all these different products like this, where it's zero code, but it's still a lot of responsibility that goes with it of making sure your models aren't biased or they're responsible models. So yeah, skills kind of can be really easy at times to pick up, or if you're using zero code solutions like this, you're ready to go in a day. Like that's all you really need to train yourself. But to actually understand what you're doing with your data and those kind of skills are a lot harder to get. So that experience is still needed. So yeah, I think it's a lot more demand ready to be used in Australia, I think.
Yeah, that's a good point, actually. Yeah, that's a good point. You just mentioned experience, right? So even for people who are starting right now with machine learning or AI, actually, if they look forward in 2 or 3 years, they're going to have experience. I think that experience that is going to be highly demanded in this market.
I mean, even if it's just you doing random things in your free time, like if it's just setting up a random pipeline like this, you'll start noticing even just smaller things. You're like, I wouldn't have known that. Picked it up, off you keep it going. Like, especially from my point of view, like I work in consulting, every client that I would work with is completely different context in a completely different industry. So coming into those is like, okay, I now have to take a step back and try and understand their data and their context for why they're trying to do this or why they're trying to put machine learning or smarts behind it. And that, honestly, no matter how many skills you have, and this is coming from like our lead data scientists at work too, it takes time to build that skill of understanding really quickly what the context of your data is. And that's a valuable skill to have. So if you're just even if you go on Kaggle, try a few different projects, knowing the different intricacies of different data sets that's really, really valuable. I mean, I'd really recommend that.
Yeah, definitely. Okay, thanks a lot for getting involved. Thanks again. All the work that you're doing for the community is great. Please keep doing the same.
Always.
I'm looking forward.
Yeah. If there's a place for low code talks to be done, I am all about it. I want everyone to be doing machine learning at this stage.
Okay. Cool. So thanks a lot for the attendees in the YouTube channel. Please go on to the webpage and start submitting feedback for the different presentations. Thanks a lot, Akansha. We're looking forward to having you in a different event in the upcoming months. And yeah, have a good weekend, actually.
Oh, thank you. I will actually. Got the sun shining down. We'll cry with some hay fever outside. It'll be great.
Okay, take care. Bye. Okay, guys, for those ones in the YouTube channel, before we start our last presentation with Josry, actually, and talking about tips and tricks for robust big data applications, I'd like pretty much to highlight that if you want to submit feedback for any of the presentations, come to the BrisbaneBootcamp.com webpage and pretty much submit the feedback. You'll need to open each one of those presentations and submit the feedback. Another key point, actually, if you want to opt in for the prizes at the end of the event, you'll need to be registered as part of the Eventbrite event, as well as to submit feedback for the prizes. So right now, pretty much we are going to go for a short break around 7 minutes before we kick off our next presentation with Josry. He'll be covering actually an amazing topic, when you're working with machine learning AI, you need a lot of data. And he's going to give us some tips and tricks for building robust big data applications. So see you again in 7 minutes. Stay tuned. Good afternoon, Josri. How are you?
Well, good afternoon. Good morning, David. How are you?
I'm getting confused. Our previous speaker was from Melbourne. You are from Queensland, but you both work for the same company. I'm just going with the flow. That's correct. So how's everything?
Everything is good. Amazing.
Okay, you're feeling that right now here in Brisbane, actually it's really hot. It's starting to be hot today, right?
It's starting to be hot, but I mean, judging from my ethnic background, I'm originally from Egypt, so I don't consider it hot.
That's a good point. I need to ask, how hot does it get in Egypt?
I mean, it depends on the location, but normally it's above 35 or maybe 40 in summer.
Okay, cool. Yeah. Okay, correct me if I'm wrong. I think this is the third year in a row that you're talking and supporting the Brisbane AI community by speaking at the event, right?
Yeah.
It's great to have you on. It's great to have you on board. I think today you're covering a topic that people need to know about. You know, when working with machine learning and AI, big volumes of data, they are usually required, and you'll be covering that, correct?
Yep, correct.
So how do you come up with this topic?
Actually, this topic is based on the real experience we had at Telstra. I was working with the big data applications, a certain type of application. I don't have to mention the specifics, but it was starting with Spark, different versions of Spark and Hadoop, and we have our own on-premises big data cluster and stuff like that, and starting from a little bit, very little knowledge about the whole thing, and then trying to build the experience and knowledge and improve things here and there. So eventually, I'll come to that in more details, part of the demos. But the idea is that we have lots of problems and challenges initially, and then gradually we started to improve our setup eventually so that we can service clients now more reliably and very fast. So yeah, and you know, as a developer originally, you would like to have your life easy. You don't like to have difficulties every day and lots of wait time and problems or whatever. You want to have a very smooth experience in your daily workload. So yeah, this was also one of the main goals.
Okay, amazing. So it's based actually in a real experience, real project, right?
Yes. The product, I mean, for anyone interested, it's called the Telstra Location Insights. There is a little bit of marketing and changes around that currently. But if anyone is interested about learning more details or whatever, you can reach out to me and I can have a chat with you, or maybe connect you to one of the salespeople, and then we can take the conversation further.
Awesome.
But eventually, yeah, my point is that even now it's much more important now to work with data, and since the early days of people or men, people were kind of counting things, and it is even more important now. I mean, other than all the hype and buzz about AI and deep learning and such things, still one of the most important news you would like to hear every day, at least for now, is how many active cases of COVID in your state. That's kind of one of the important things you need to measure, and whether a certain community is recovering or not. So yeah, still counting things and big data is very important and relevant.
Okay, that's an excellent point. I think it's a perfect transition actually to give you the stage so you start your presentation. So right now I'm going to add maybe your screen and
switch this one. Okay.
Cool. So are you ready to go?
Yeah, so can you see my presentation? I mean, just in case?
Yeah.
Okay, very good.
Awesome, Josri. Thank you.
All right. Thank you, David. All right. So good morning, everyone. Assuming you are in Brisbane or Queensland, and good afternoon, good evening, anyone else. My name is Yusri Mohammed. I work as a lead consultant at Telstra Purple, and I'm here today to talk to you about some of the tips and tricks for building robust big data applications, developing them, deploying them, and operating them. And just for the sake of the time, I will not talk too much about myself or whatever, but I'll start a little bit of journey, my professional journey here in Australia. So I started with Redify a few years ago, and then Redify has been acquired as a Telstra company. just giving you an idea about how I had the chance to work with big data applications. Then eventually there was a rebranding inside Telstra, and we have an entity or a brand now called Telstra Purple. And as you might expect at Telstra, we have lots of big data assets and big data applications. So hence you will find the yellow elephant, which is kind of a visual indicator of big data, the Hadoop kind of ecosystem. All right, so a little bit of history, not around myself, but around Hadoop itself or the big data ecosystem. So everything started around 1998 with Google. So Google wanted to index the internet, which involves processing huge amounts of data. And then eventually they invented MapReduce as a new computation algorithm or paradigm to handle big data. And then based on that, this kind of inventions and requirements, Hadoop ecosystem has been introduced. This is a V1 thing. It was like what at that time it was pretty cool or amazing, but according to the standards of today, it was very slow and cumbersome. And then this was a new resource manager because Hadoop was originally slow and having problems with resource allocation because it's a distributed environment. And then to make things much more fast and user-friendly, some people at, I think, UC Berkeley introduced Spark so that lots of computation can be done in memory and fast. And also many people with SQL skills like SQL DBAs, administrators, or business analysts, or anyone really with SQL skills can use Spark. And just recently, a few months ago, they have introduced version 3, which is about lots of new features in the platform itself, stuff like Delta Lake, and also allowing Spark to run on environments like Kubernetes. So yeah, this is the latest and greatest stuff from the big data community. So the agenda for today is kind of 6 major tips. We'll start with every one of them with like what an individual demo. So we'll start with a bit about your data and the storage format for big data applications, and then we'll see what will be the impact of certain underlying file systems, and we'll see how big data applications are kind of designed to be balanced so that there will be little skewness. We'll have a look on the QA of big data applications and how things can be done in that aspect. And we'll wrap up with a bit on governance, lineage, security, and stuff like that. And finally, some ideas around the tooling and how could it help in your daily workload. So let's start first with your storage and data. So big data is normally about, when someone talks about big data, he will usually mentions the 4 V's or 5 V's or whatever. I mean, so, and the first V will be volume for sure. Okay, so big data applications, mostly we store our data as blobs or files on some sort of a file system, a cloud file system or on-premises file system. And you need to understand if there's a proper HDFS file system or Hadoop distributed file system, or if it's something like a blob storage or a blob store or object store like Azure Blob Storage, and that might make a difference. Plus, for sure, the idea is that most of these big data applications, we store data in 2 common data formats. One of them is called Parquet, and the other one is called ORC or ORC. And then you need to understand the schema of your data sets, what type of columns you have. Is it like what plain columns like integers, float, and stuff? Or you have arrays or more sophisticated or nested data types? And then you'll need to assess your data, have a look on it, and see if your data can be compressed more or stored in a little bit less size, so that your subsequent pipelines will run fast and efficient. Because it's not about storing as much data as you can. It's about storing them in an efficient fashion, so that the whole pipeline will be fast and quick. So let's go to the demo here. I switch to, too many windows, VS Code, and our first demo will be about how your the scheme of your data and how certain columns are stored will make a difference. Okay, so what I have here, actually, because this kind of demo takes like some of the steps take a few minutes to execute, so I've run the script, but I'll show you the ideas step by step. So what we are going to do now is to create a small table, an ORC file. Think about it like an Excel table or something like that. And at every step, we'll add or update the data type of a certain column, and then check the size of the outcome data set. All right. So here is the first step. This is like what Spark code running on my Windows subsystem for Linux virtual machine or something. So you just run the Spark shell, and this kind of statements, you can run them in the shell. And by the way, I leave a link to all the demos and the source code in the chat shortly or later after we are done. So I think if anyone, I'm not sure if you can see my, just asking if people can see, where is that? My Visual Studio Code.
Right now we can see your Chrome. So
no, I mean for now, can you see my Visual Studio Code?
Yes.
Okay, very good. Just in case. All right. So first statement here is about creating a data frame, 10 million rows, I think. Okay, and then storing it at a certain place on disk. Okay, and then with every step, we'll be showing the a subset of the data or the first 5 records or something. All right, so 10 million data set stored as ORC file on disk with a single column, which is just a sequence number, is around 200 kilobytes. All right, let's think about adding a string column. Okay, so the next step is to add a string column. It will be a prefix and some random number in the range of million. So we have like what 10 million unique, random combinations of that string. So you can see here that we still have the sequential integer, and then we have a string column and lots of random numbers here. So we have lots of unique combinations. So eventually, when we add this kind of string column, our data set size will jump to 71 megabytes. I hope you can see that. Okay. So if you like dig deeper into the documentation of such storage formats like Parquet or ORC, you will identify that strings are stored as dictionaries. All right. So depending on the cardinality of your column, your data can be compressed well or not. So because the dictionary will be smaller and stuff like that. So let's assume that we'll decrease the cardinality from, you can see here the cardinality initially was kind of 1 million. Let's assume that we'll decrease the cardinality to 10 unique elements only. So we still have the string column now, but with smaller cardinality. I mean, like 10 unique combinations of the string value. All right, you can see here that now we went from 71 megabytes to 5.2, which is a great achievement. Okay, so just know that depending on the cardinality of certain columns, especially the string data type, data can be compressed better. Because yeah, this kind of columnar data formats, they're stored as columns and stuff, but they also have built-in compression. Okay, so the next idea here, just to prove that the size of string itself does not matter actually, and the only thing that matters is the cardinality, or it doesn't virtually matter. Okay, so the next experiment here is that the same string column, but I've made the prefix and suffix too big, or almost like a double-sized text. Okay, and let's have a look on the size again, and it is almost the same actually. Okay, so this is just an evidence that okay, if you have a string, it doesn't really matter how long the string is, as long as the cardinality is the same. Okay, so the next step, let's like play with constant columns. Even like integer columns, like that sequence thing or identity column, they are still compressed. But we normally know that compression, when you have constant data or things that are just repeated, compression will work better. Okay, so in this data set, we have like one extra string column, a constant one actually, and one extra. I mean, if you can have a look, scroll down here. Yeah, there's a code for that part. Okay, line 53 here. constant string and a constant float. And let's have a look on the size. So once we add the 2 extra constant columns, the size increased a little bit, but it's mainly like what a bunch of metadata here and there and this kind of things, just overhead. But actually, constant columns can be added easily without too much impact on the final size. All right, cool. So let's assume that you have in your data set some sort of a complex data type, a struct or an array or something like that. So here we'll be just adding this snippet of code, adding an array of 100 elements, and in the array itself, the cardinality of the array, it's like what 1,000 unique array instances. So I'm adding an array column here, and let's see what will be the impact on the size. So if you scroll down here, you will see that introducing an array column, like what exploded the size to almost the range of 1 gigabyte now. I mean, approaching 1 gigabyte. Okay, so just know that if you have arrays or nested data types or these kind of things, you will lose lots of like what compression, or I mean, data cannot be compressed similar to stuff like strings or whatever, because I mean, it will not be stored in a dictionary or stuff like that. It will be just like what stored as is, as like what a string of bits and so on. And it depends on, I mean, the encryption algorithm, compression algorithm, or the format of the column itself. So sometimes you might really get very big data increase just due to the introduction of an array column. So what can we do with this kind of column to limit our data size a bit, or maybe greatly, especially if the cardinality of this column is small? Assume that for any reason, yeah, you have 10 million records in your data set, but eventually the unique combinations here are like what 1,000 or so. So the trick here to if you can store that column or serialize it as a string using any kind of approach like comma separated values, or serialize it as a base 64 or something like that, or JSON or whatever. So the next step here, I'll take that string, array column, and convert it to a comma separated values string. Okay, so originally here it was an array, if you can see the square bracket, and now, I'll store it as a string, a plain string. And you can see here that the size dropped from 974 megabytes to 13 megabytes, which is amazing. Actually, it's kind of 2 orders of magnitude. I know this is a synthetic data set, but eventually, I mean, or practically what we had in terrestrial is something like what a daily data set of 300 gigabytes. And with a combination of such ideas here in this kind of demo script, we have like what decreased the size, the daily size, from 300 gigabytes to less than 30, which is an order of magnitude, which is also like what improved the performance and the speed of lots of subsequent jobs in the big data pipeline. So eventually, if you can store your data in an efficient way, I know there will be a little bit of deserialization if you'd like to use that array column and stuff like that, but it's a very minor computation cost that you can pay for going from 900 megabytes to 13 megabytes. So these are just like what a glimpse about some ideas around how to store data and how to optimize your storage. So eventually, yeah, you will pay less for storage in case that matters to you, and other jobs that will depend on such data set will run much faster because I/O. Okay. So I think this was a first step about storage and columnar data format. And this is something around some key takeaways here: cardinality and knowing your data types and stuff like that. Just wrapping up most of the ideas in that Scala script. Let's go to the next idea here, which is about your file system. Sometimes you might have, I don't know, a bit slow file system due to whatever reason. The name node itself could be, on your Hadoop cluster, could be slow, or it's an object store system. So enumerating folders and digging deeper into folders will be slow. So you need to identify also what are your access methods. I mean, do you access, for example, if you are having an application, a plain application of your Windows machine or Linux machine or whatever, you can access a certain piece of data using C/blah, or you can have a network share format or something like that. And there is a difference between such access methods. And then sometimes you might need to add a little bit metadata to your big data applications to make things fast. And we'll have a look on that now. So because metadata is something like what when you are running a SQL query on SQL Server or Oracle or whatever, and the query is slow, the first thing you might think about is, okay, let's add an index. And an index is also a metadata thing, something like what we are going to do today. So back to VS Code. And we'll go to the next thing. So in most big data applications, data is stored in this kind of format. I mean, partitioned by some sort of a dimension, like a date or department or whatever. So you'll find some data here partitioned by year and month and day and so on. Okay, so what we have here, let me just go to that location and fire Spark Shell. I have a small data set here, partitioned using year, month, day, and it is stored twice. Once on, let me have a look here, on my Linux file system, and once on my Windows file system, and I can access both from my Linux machine. Okay, so let me give you an idea about the difference in access or speed. So I'll do this command, which will list the sizes of folders from the Linux file system. You can feel it is very fast here. But from the same WSL virtual machine, I'll hit the same data. It is another copy of the same data, but now it is stored or accessed on my, mounted C drive on the Windows machine. I think you can feel the difference. Okay, so yeah, depends on where your data lives. Your access to the file system itself could take some time, especially related to enumerating files and folders and stuff like that. Okay, so I'll go back to my Spark Shell here, and I'll run some queries that is loading data from the Linux copy, just doing a plain filter using the year, month, and day, grabbing a week of data. I got some sort of bootstrapping stuff initially in Spark, but this query actually is pretty fast, okay? And if I try to do the same query against my Windows copy, you will feel that it will take a few seconds. Even if I repeat it again, I just don't want to waste your time. But this query, although it is doing the, accessing the same data, but data is stored in a different file system, kind of, or accessed from a different file system. So the query will take much longer. And if we switch to Spark log here, or Spark console or history server, you will notice that, this is the first run of the statement, from the Linux file system, and there's the same run from Linux file system. The other run from the Windows file system, it appears to be quite fast as well, but that was not the case. There will be some hidden work done by Spark behind the scenes, which is to just go find folders here and there and enumerate them and find where the data is to be retrieved. Okay, and it is a bit misleading that this kind of thing sometimes it doesn't appear here on a Spark. So you might think that your jobs are fast, but they're not actually fast. So to handle such problems, especially on slow file system, which is my mount C drive here, we have two kind of tricks. The first one is to try with some Spark API to provide the base path, and then specifically mention the folders you would like to grab the files from, or your data from. So I know I need the first week of October 2019, so I'll put this path, and then I provide an array of strings. Every one of them will contain one folder. And then I'll put paste here to paste these couple statements and run. And you can see it was very fast. We got the same result, and it executed quickly. So if you'd like to do it this way, that would be totally fine. But I think this is a little bit clunky and not very easy to use in most situations. So the other approach, like what I've mentioned related to speeding up normal SQL queries or whatever, is to add metadata. And the metadata that we can introduce here is to use a tool called Hive. So think about Hive like providing an extra abstraction layer on top of this file system things. So it can tell, okay, if I'd like to go grab first week of October 2019, I'll need to go into these specific folders directly. I don't need to go and list folders and do searches or whatever. So I'll create an external table thing, which is just a layer on top of the data. It is not the data itself. The data is still stored into my Windows file system. So I'll just create an external table on top of that, and I'll instruct Hive to partition, or inform it that the data is partitioned by year, month, day. So I'll grab this thing. This is just to create the metadata. It will take a few seconds to build the metadata for the table and so on. But eventually, if we hit the same, or run the same kind of query, but now not against the plain file system location, but actually against a Spark table, I'll grab the same query, assuming Hive is helpful and done. Okay, we're done. Grab the same query, hit it quickly. Yeah, so that's it. So sometimes you might need to think about your underlying file system. Does it take too much time to enumerate folders and stuff like that? And do you need to have another layer of abstraction or indexing or whatever to make your queries run fast? So this is just an idea or a glimpse about what would be the impact of different file systems on your big data pipelines. Let's go to the next one. So the next one, so pandemic time, I'm not sure if everyone is going back to the gym now or what, but normally when you go to the gym and pick a couple dumbbells, probably you will pick dumbbells with the same weight. It will be very unusual to pick 10 kilograms here and 20 on the other hand. Does it make sense? So the same applies for big data applications. You need to distribute your compute load as fair as possible across all the nodes you have on the cluster. And the same applies for the storage. It's not so good to have your data set stored as 20 files, where 19 of those 20 files are very small files and one file is a very big file, because big data is normally done over distributed infrastructure, and every node on the cluster will pick one of the files or two of the files or something like that to process. And if the files are not already of similar size, some of the nodes will be heavily loaded or something like that. So generally speaking, it's also always recommended to have your applications work in a balanced and fair fashion. All right, let me give you an idea about what I'm talking about here, because seeing is believing instead of just talking concepts. So let's move to skewness ideas. So I think I still have the same Spark stuff running, so I can come here. But actually, I'll kill this one because I'd like to start with a fresh shell, because I'd like to show the stuff in the console simply without confusion. So what we have here, until the shell is ready, I have a small data set containing some sort of geographical information. All right, it's not very huge. I don't remember, a few hundred megabytes or something like that. And then let me just load this data set and show the first few records. Okay, it's a simple table, some geographical information about Queensland or places and stuff like that. Then in most, or actually in the MapReduce itself, the idea of MapReduce is to go pick some data, filter it, do something with the filtered data, and then store it to disk or stuff like that. And the same applies here. Many queries will start with loading data and then doing a filter and then maybe doing some sort of transformation or mapping. and then eventually storing to disk. So what I'm doing here, I'll filter the data for a certain city here in Queensland, and then like what store data to disk. But we have different APIs for storing data to disk, because you have an option to control how many files are generated. Because big data is done over distributed infrastructure, so you have multiple nodes running in parallel, and every one of them is generating a piece of the outcome. So you don't have a single final file outcome. All right, I'll take this one and run it, and I'd like you to notice what will appear now in the console. So there's something called the coalesce, which will take the data and store it in 4 files. You can see here, there is a 4 here, if you can notice. So this kind of 4 means like what this query, in this API, it has a bad side effect that it will limit the number of threads running or servicing this job or query to 4, which is not good, especially if you have lots of compute and a heavy or complicated query. So this one finished, it's not a big deal, but if your query was like much heavier, that would be a big problem. There is a similar API called repartition, and just to let you know, I have 12 cores on my laptop, and have a look here. You have 12 here, meaning Spark is like creating 12 threads to run this query. All right. So if we go now, just to give an idea about why this matters, I refresh the screen now. So the first one was the show one for displaying the data. This one was like choosing the coalesce API. It took 5 seconds. Okay. The other one was like doing using the different API repartition, and it took 3 seconds. Like maybe two times faster or whatever. But actually, if you try this against a real big data set, the difference will be very, very radical. Okay. And you can imagine here from this kind of thing, the first query was running against like 4 threads only, and or actually this kind of how much parallelism Spark is doing to run your job. And this one is like 12 jobs to do the filtering or something like that, and then 4 additional jobs to do the persistence of data on disk, hence the 16. So if you even don't care about the speed or whatever here, let's have a look at the final data. Skewness. So this is the data from the first API, coalesce. And you can see here that, yeah, like data size is not very consistent. Some files could be small, some files could be a bit large, all right, which is not so good. But if we go to data repartitioned, the other API thing, they are producing effectively the data is equivalent. I mean, they are pretty identical. But the file sizes here, look at this one. This is very, very balanced data set. Okay, so I mean, using the correct API, just you need to consider what APIs you are using and whether they are like providing or having the what is that? Doing the needed parallelism and not keeping your jobs very slow. You might have like 100 cores available, but your job for whatever reason could be using only 4 out of them. And for sure, you need to consider making your final files or your output data balanced. All right. So this is about gem and balance. So next thing, I hope this is not related to COVID, but yeah, it's more about data quality. In big data applications, we always use the classic things like all other types of applications. Still, unit tests and integration tests are useful and recommended. But because big data applications normally run as like background jobs or batch jobs or even streaming or whatever, and you don't usually have a screen open in front of you to play with the application and see like a normal web application or whatever, thing is most of the time run in the background, and you better know or like put some measures to test that the quality of your outcomes or whatever produced from your jobs or processes is good, because otherwise there could be problems and you will be in the background. No one would know until it's a surprise, and probably it will not be a good surprise. And you will also need to think about notification and diagnostics. So think about it. You better put some like what logic at the end of your jobs, or maybe at the beginning as well, to check if the input data is good or not. And more importantly, at the end of your jobs, make sure that the final outcome of your big data application is good and it makes sense. And if there's a problem, you can like leave some logs and diagnostics, and maybe also do some notifications so someone will take action fast or quickly. All right, so I'll go quickly through this one because, yeah, for the sake of time. So what we have here, sorry, what is that? Okay, I'll exit this one. And I'll be using a library from AWS called DQ, which is providing some sort of declarative data checks against your data. So what we have here, let me show you a small thing. So I'm joining some data from two CSV files, one of them containing some customer orders, one of them containing some country information. So we have country, there's a country table, there's an order table containing a country code, and I'd like to join them to have a final data set containing all the information about orders and continent and region and stuff. And this is the joined data set, okay? So I'd expect that this data set, it should have a unique order ID, and cell amount should be always positive and doesn't contain null and stuff like that. And if any one of these kind of constraints fail, there should be a problem. I mean, I can fail the job or send a notification or whatever. So this is what we are talking about here. Just implement, grab some library, doing some sort of declarative checks against your data, so you can provide it with a data frame and tell it to apply some certain checks, data quality verifications. A certain column is unique or complete or whatever. So I'll just define this function. Okay, it is defined, and then I can run this function against my data set, which is the orders with country information, and it can tell me like what if it is okay or not. And if it is not okay, you can dig deeper into problems. I mean, it can tell you what column has a problem or what kind of condition failed. All right, so let me show you a simulation about when you are doing unit tests, you always prefer to test the failed condition and the successful condition and so on. Yeah, red and green stuff. Anyway, so I'll fake a duplicate country table, because sometimes some of these kind of data sets are owned and operated by other teams, and you don't have control on such data sets. Sometimes you have rubbish data in, and you'd like to guard against that. So I'll simulate a duplicate country table. So eventually, our final table here, you can see that you have two records for the same order, because eventually we had in the country table we had two records for the same country, which is bad. Okay, so let's apply the same thing, and I can imagine you understand, or you are guessing what will happen now. So we'll get an error. So based on this kind of check, I mean, you can grab that status and implement some logic in your application to fail the job, send a notification, do something about it, or at least leave some traces in your logs or whatever about what's happening in your applications, because that would be very useful for later troubleshooting and diagnostics. All right, very good. So that's it about quality. It's normal kind of advice: garbage in, garbage out. All right. Cool. Nearly there. So what's the next thing? Governance. All right. So the boring stuff here. So most of us will not be very excited about doing such things, but eventually, when your big data cluster grows and you have heaps of data sets and jobs and processes running here and there, it would take more than an Excel sheet to handle all this chaos. So eventually, you will need to have an asset catalog. You'd like to have some tool to help you, I'd like to go and find a certain data set that was generated last year before we had a certain partnership with a client or stuff like that. So an asset catalog is very important. Plus, for your own or most of your critical data pipelines, you would like to have a lineage. So you would like to understand if a certain data set is produced, what were the input data sets, or if there is an input data set with or a certain kind of data set identified to have a problem, what were the impacted other outcomes or applications or whatever. So lineage is very also critical. Plus, you would like to have some sort of classification and tagging thing, because things like what we have lots of data sets. Is it some of them could be financial or confidential, or they contain PII information or cannot be shared with external clients or whatever. So yeah, you need to have some sort of automated tool to apply the tagging on that asset catalog. Plus the integration of all these kind of 3 bullet points of the catalog and lineage and classification will also contribute to security. You'd like to handle security in a more smart way. So if a data set is tagged as confidential, it can be, a certain security tool like Apache Ranger can be used to automatically set correct role-based permissions. So you don't need to go and remember and do things manually here and there, and eventually you will forget to do things. Okay, so let's have a look on lineage, or actually governance. So the most important tool, or maybe the most common tool for doing governance with Hadoop is called Apache Atlas, and it can integrate with Hive and Spark and many other big data applications. Where is that? So what I have here, I run a very similar query, joining orders and countries and producing a certain data set. But I'd like to have this kind of job, a very simple job, in a more kind of managed way, and data sets should be tracked, and there should be a lineage, and we'll have classification and so on. So let me give an idea here. I'll switch now to a Docker container containing Spark plus Atlas. All right. So here is my container containing the CSV file for the input data we have, plus my demo script, which is very, very basic thing, reading some CSV, doing a join, and writing data to disk. Nothing magic here, except for when we trigger the script, we have a bit of integration with Atlas itself using some kind of Spark magic and an open source library from Databricks called the Spark Atlas Connector. So paste, run this stuff and hope for the best. Okay. It will take a few seconds, but I just want to wait because, yeah. Okay, so this is the data set to be written. Yep, an order table with a bit of country information, and everything is done. So I'll switch to Atlas web console, which is hosted on that Docker container. So I log into Atlas. You can see here that you can track certain data sets. So for example, I can switch to the advanced mode, and I can track stuff. These are kind of artifact types. So we have something called FS path, which is a data set stored on a file system, on a plain file system. There is also something like HDFS path, which is a data set stored on a distributed file system. We have stuff like Hive table, Hive column, Hive database, and so on. So I think the data set was called, I hope the free text search is pretty reliable now, so I can grab this one, put it here, and you can see that, okay, I can use plain text or maybe some sort of other advanced Solr-based SOLR, in case you need to Google it or whatever. Free text searches to find out my data sets, and there are lots of other advanced search features. So if I go to this one, there is a data set generated. I think there should be something about timestamps and so on, maybe. But eventually we have this outcome data set, and then I can come here, have a look on the lineage, and then I know that, okay, this data set came from the orders and the countries through an application, a Spark application called Bootcamp application. These kind of things can have timestamps and so on, or whatever, or versioning. But eventually I know the origin of this just like what, because this week was State of Origin, and I'm still excited about it. Just pretending to be quite linked to football, although I'm a soccer fan. But yeah, so you have a lineage here, and on top of that, what else? Let's assume that we'll go to the orders data set itself. So these are the orders, and someone told me, okay, the orders data set, it contains financial information. So this data set should be tagged what financial or important or whatever. So we can create some classifications, and then you can apply a certain classification on one data set, and you can take that propagate, so that if any other data set is like what produced out of this one, the same classification will be applied as well. So I click add here. All right, cool. So I'll go and search for my, have a look here. If we come here, we'll find that we have a financial classification, but we are on the orders data set. But if I switch back to my orders enriched, which was the output data set, I can see that, yeah, the same classification has been propagated. And yes, this one is also market financial. And if there was any kind of security logic or permissions to be applied automatically, it will be applied on this one as well. And if we run the same job once again, and maybe produce the data in a different folder or whatever, the new data produced will have the same propagated classification. So these are just like some ideas about how to use tools like Apache Atlas to help you having a catalog, an asset catalog, applying classifications, and maybe integrating with other tools like Ranger to apply security in a smart fashion. So yeah, governance does not have always to be boring and dull. All right, cool. So finally, I think almost like maybe out of time, or just like give me 2 or 3 minutes. So about tooling. So normally, the tools that come with the most of on-premises big data infrastructures are somehow boring and not very easy to use. So the idea is that our workload normally will be most of the time interactive queries, and then you can grab this kind of queries and bundle them in a jar or whatever and deploy them as a batch job. You need to have source control integration and nice diff experience, which is not the case for Jupyter notebooks a long time ago, but there are ways to handle that. And there is also options to have pipeline notebooks, so that if you have a big problem, you can divide and conquer your problem into multiple small notebooks, and then you can pipeline them together, instead of having a very 500 lines notebook, which is hard to read and hard to manage. And you would like to have a tool that will have a very good local experience. You can develop most of your stuff or proof concepts or whatever locally, like what I'm doing today in this talk. Plus, you'd like to take the stuff that you have developed locally and just push it to be run on the cloud. Like Akanksha mentioned in her talk, there was this kind of Azure compute. You can have a compute cluster, so you can try with a toy data set and then push it to the cloud to run against the real big data set if needed. So I'll show you a small tool here to help with that. There are other tools like Kubeflow and stuff like that, but I'll go here to one tool called Elira. I think originated from IBM or something, but here is the documentation. It's called Elira, in case you wonder, and this is a GitHub repo. So you can, it's just a group of extensions on top of Jupyter Lab, okay? So let's assume that we have 2 notebooks here, and actually it has very good Git integration. You can, this is my GitHub repo itself, and then I can go pull from remote and stuff like that, and you can get, I think there will be some changes because I put some stuff this morning. Okay, cool. And then you can have a look here. For example, if you wonder on the changes, or history, you'll find, okay, yeah, you have all the magic from Git. You can do all your stuff here from a single environment. You don't need to jump between tools here and there. But what I'll show you now is the divide and conquer idea. Let's think about, okay, most of my talk was about big data and counting things and stuff. But let's switch to something similar to what we have seen this morning, which is about classification and plain AI machine learning. And one of the, what they call it, the hello world types of machine learning applications is Iris database or Iris dataset, similar to stuff like MNest and so on. So it's about classifying the species of a certain flower. All right. So we pulled the repo, which contains two notebooks. I can run the whole notebook here, so you can divide your work. So where is that? This notebook maybe will be about pulling data and doing some sort of exploratory data analysis. So I'm pulling some data from a remote location, could be your own, I don't know, network file share or whatever, and then showing some data here, displaying some set of statistics or whatever, and then doing some exploratory data analysis to understand more about your data. You can have another notebook about, okay, I'll take this data which has been downloaded locally here, and then do the train test split, use a library like scikit-learn or whatever library you prefer, do the machine learning or decision tree training, very similar stuff like what we have seen with Machine Learning Studio or the designer, but this time written as a plain Python code, all right? And then I run this one, okay, run it. Okay, cool. We got a result here, but let's assume that this kind of two notebooks were prepared by a colleague of mine, and okay, looks good, everything is fine, as if I'm just reviewing a branch or PR from him, but I think there is it can be improved. So let's go here, for example, and change the depth of decision tree or max depth parameter to 4 and see what kind of performance or accuracy you can get. So I'll run this one once again. Okay, increased from, I think it was 91 to 95, which is quite good. Cool. So I can maybe save this one and share it with him or create a new commit or whatever and give him some feedback. But the idea, if you'd like to really test what are the deltas, what has changed, it could be too many changes implemented in the file or the notebook, you can switch to your Git node here, switch to changes, hit refresh. It can tell you like what notebooks have been modified. I can double click notebook number 2, sorry, and click def. If it takes a minute or so, close this one, right click def. No, it doesn't show for some reason. I'll open it and then maybe def once again. Anyway, it seems something was going wrong, but eventually, if I had a screenshot, you'll see that the def experience is pretty good, and the deltas will be around this value, which has been changed from 2 to 4, and this value, which is an outcome of the cell. So eventually, we'll have a very good def experience. Maybe this one will work. No, yes, I don't know, but it seems that I need. Yeah, it's the first time I did this kind of demo like 2 or 3 times before, and yeah, unlucky today, but all good. But I think you get the idea. You will find very good local development experience here, including all the expected stuff from Git integration and source control and so on. And eventually, you have also the option to go and create a pipeline so that you can have one notebook doing a simple task and another notebook doing another task, and then you can connect them together and run them locally or run them on a cloud environment. So this kind of investment in tooling will save you lots of time. And if you are interested in similar tooling for Spark, not for plain like data science or machine learning, there is another library called Spark Magic, which is virtually doing a very similar thing and working on top of another application called Levy. All right. So that's it. I think I've talked like I don't know, 5 or 10 minutes more, maybe. I don't know. I think this agenda you have talked just quickly around data storage and file systems and how to balance your applications and how to do proper QA and governance, and finally how to pick good tools that will help you and make your life easy. So eventually, a combination of such things will allow you to have efficient big data applications and pipelines, and eventually can deliver faster, because it's not about having cool tech or whatever. It's more about value. It's more about customers. So yeah, using this kind of ideas or tips or whatever might help you with your journey with big data. And I'll leave the link for this kind of scripts and demos in the chat shortly. And thank you so much, and happy to listen to your questions. And sorry for the extra time I took.
Hey, Josie, thank you for that presentation. I really appreciate it. Thank you for getting involved, actually, one more year. As per questions, actually, I have a question for you. So I've seen in your presentation, actually, that you've been using Apache Spark pretty much for everything. Why should people look at Apache Spark and not any other big data clusters, for example?
Could be many reasons, actually. Some of them could be maybe bias or personal preference, but the big selling point for Apache Spark is that it's open source. It can run everywhere, so you are not kind of linked to a certain vendor or cloud provider. So if you have your code and jobs or whatever implemented in Apache Spark, you can take it from Azure and deploy it with AWS easily. It should work. Plus, most of, or maybe at least Microsoft itself, the latest inventions and stuff like I think Synapse Analytics, they have two variations of the tool itself. One of them is just to use plain SQL, if you are just happy to just use high-level abstractions like SQL, and the other option is to give you a pointer to a Spark underlying environment. Okay, so you can just write your Synapse Analytics jobs in Spark. Okay, because sometimes your jobs might be a little bit more sophisticated and cannot be done in SQL by itself. You might need to reference some special libraries or some custom logic that cannot be done using SQL. So yeah, Spark is pretty amazing, plus a very big community around Spark itself.
That's a good point, because I was about to say actually that when you think about Azure Databricks, or you think about Azure Synapse Analytics, or other platforms in Google Cloud or Amazon Web Services, they have actually they have built like wrappers around Apache Spark.
Yeah,
good point.
Yeah, but other than the tooling itself, it's more about also whatever tool you use. As you have seen here, some of the ideas were around pretty basic ideas, like you might need to know if what the data type of float will be stored as 4 bytes and the data type of double is 8 bytes, and do you really need the accuracy of double, or is it good for you to proceed with the float and stuff like that? So regardless of the tool, I mean, whether you use if you use Spark for 2 or 3 years or whatever, and then transition to some other tool, Synapse Analytics or AWS or Google or whatever, most of the learnings you have done using Spark will be also applicable over there.
That's an amazing point. Okay, thanks a lot for getting involved one more year. What's the best way for people to contact you if they have any questions?
I think that my Twitter handle over there, and can also reach me on LinkedIn. My name is pretty unique, so you can find it easily. So yeah, I mean, and then we can take it from there. Yeah, I'm pretty happy to have a chat with anyone interested.
Awesome. Take care. So next up, we'll have the closing and prices. This is spelling mistake in prices there. Okay, but take care, Josie. Amazing presentation. Looking forward to have you next year as well. Bye.
Thank you so much, David, and have a good day, everyone.
Okay, that was the last presentation for this event, but this is not over, actually. What we'll do next, we're going to invite our other organizers to the stream once that they enable the camera. Pretty much we'll go to the closing of the event and presents. Hey, JK, Sarat, how are you?
Hey, David. That was a great presentation. It was a great event, actually. It's quite a lot of different topics to talk about, and I hope people enjoyed them.
I think there was a lot of good.
Okay, before we summarize the event, so what I'll do actually, we're going to show the attendees what they need to do actually to be able to opt for the prices. Let me find the window that I'm looking for. Then with the WordPress, they will make for us.
So just in terms of the prizes, so what we're looking to give away for finishing all the feedback for us is basically $50 JB 5 vouchers to everyone, which we'll mail out in the coming couple of days to the winners.
Okay, what you need to do, this is my mistake because I'm in the edit option. So let me update the different website. So what you need to do is pretty much to go to the brisbanebootcamp.com website and go to this program section and make sure that you submit a feedback for the speakers and attendees. So you'll scroll down and we have amazing speakers today. We're going to summarize some of the key points, but the idea is for you to come to this section and click the different links. All of them are enabled now to submit feedback for the different speakers and for the event. So if you do that, we'll wait maybe 5 minutes and we'll do the raffle. On the other hand,
sorry, David. I was just going to say your feedback will be very much appreciated by the speakers as well as for us, just to know how the event ran, whether we should continue doing this format in the future, what can be improved, that sort of thing. So yes, any feedback you can give us would be very useful going forward.
Okay, so I'm glad actually. I don't know, guys. I had an amazing day. We had amazing speakers. What will be your takeaway from some of the sessions, JK?
So the Azure machine learning was really good. Just seeing how easy you can get started with the cloud. We generally use the ML.NET route, which is essentially offline. But doing it online is also a good approach, especially if you have a laptop that it can handle the amount of data.
That's a
Smart
good point,
cities.
actually.
Yeah, smart cities. I think that one was also very impressive. In fact, all of the presentations were very impressive, but these two kind of resonated with me the most.
Yeah, I think a few of the ones that I found interesting, especially the start off with the one that Alessandro did, showing a real world scenario of how they're using AI, HoloLens, to actually guide people around their city, especially if you've got if you've got a disability like you're blind. It's a unique solution that that they are considering in Switzerland that may be useful everywhere else as well. And then obviously going into the actual details of how would you provision something like an AI solution yourself. So I think the whole couple of few sessions around that was quite useful.
That's a good point, actually, because I think we had today we had pretty much I think Akansha and Martin. They showed us that starting with the AI actually is not difficult at all. Alessandro showed us actually how the impact that can have AI in helping people. And then Geoffrey wrap up with an excellent presentation actually at all the other things actually that you need to keep in mind while working with big data applications that you're going to use for machine learning and AI. Okay, so what's next, guys? So we're the organizers of the Brisbane AI user group. What's there for 2021?
Look, we're trying to grow. So we're trying to reach more people. We're trying to get better presentations. Or I shouldn't say better. We're trying to get more presentations on AI. I'm trying to see, what else people are doing out in Australia, out in the world, come and present to us. Or help us grow as well as a group. So yeah, it'll be very useful to if you found this event useful, think of a topic, come next year, come present at our user group. It'll be fun to meet everyone over here.
Definitely. What about you, JK? You are now at AI MVP for Microsoft. You have a lot of things on your plate, okay? So maybe I'll target something more personally. So what you like to achieve next year in your area for AI?
Yeah, so for me, well, first I'll take a bit of a break for December. I think this year was pretty hectic, so get a bit of a rest, so will be good. And then next year, what I'm going to try to do is more workshops to get developers into AI. I kind of avoided a bit of the data science part, but what I'm hoping is getting data science in a way that would be close to developers, rather than saying, hey, here's all of the things you need to know, or just completely avoid it. More coming from a developer perspective. What is the minimum you need to know? When do you need to get a data science scientist in? When do you know a model is good? And just get in, and then afterwards, when you realize that, hey, this is a little bit too much for me, get someone else involved.
That's a good point, actually. Try to get more adoption, right? Especially here in Queensland.
Yeah.
Okay, cool, guys. So what we'll do, I think it's fair. We'll wrap up now with we'll close the time for the feedback, and let me go and run my. I need to capture the data. We need to capture the data from Eventbrite. We need to capture the data from Microsoft Forms. And it won't take a lot of time, but maybe I leave the conversation up to you, JK and Sarath. Maybe you can discuss something that we've written in previously. What do you think that AI is actually? That'll be a good question.
Sarath, you're muted.
That'll be a good question for the audience, really, to say, what do you consider AI? Because there is different streams of thought out there. AI could be, for me, yes, something as simple as automatically picking up a form, like an invoice, and processing it. AI could be something similar to, somebody talking on screen, text to speak, that sort of scenario. I got introduced to AI, specifically AI around gaming. So around, what are the interactions that can be completed by a game automatically in response to what you're doing. So it'll be good to understand what do you guys think is AI for you?
Yeah. The interesting thing about AI is it really depends on how you look at it. If you look from the pop culture, it basically is anything that looks smart and is not organic in essence. If an algorithm, like say in tic-tac-toe, min-max behaves intelligent, then people would be like, yeah, that's an AI. But if you look at more, technical, more people that already did some AI, that would say, it's kind of AI, but really machine learning and cognitive services and stuff like that can actually learn things over time is more regarded as an AI rather than algorithmics, artificial intelligence. So it's a really interesting thing. Like, we're doing some work with a client that is going to do genetic algorithms, and that it's all just algorithms. It doesn't learn anything. It doesn't do anything. It's just on the fly. It tries to find a good solution. And depending on who you ask, they would say, it might not be AI, but it is.
So Gary is saying it's one of the ones that Gary mentions is processing email and invoices. I'm just curious to understand, Gary, when you say processing email, at the moment, email is being, you've got rules in Microsoft Outlook, you've got Gmail that handles emails in its own way. How specifically would you process email using AI?
Yeah, that's a very good point from Gary. machine learning is a process of developing AI. And this is why there's some misconception what is an AI. Most of the people would say machine learning is the AI. If machine cannot learn, then it's not AI, but it's a little bit more broader than that.
Anyone else has any idea what their AI is?
Yeah, we have mood and posture detection. These are very interesting because if you look at the Kinect, for instance, what it does is you have actually multiple ways of doing that. One is doing machine learning. You have lots of different captured motions and stuff like that. And then you're trying to do machine learning to learn specific, postures, but you can also do algorithmically. For instance, what you look at is positions relative to other joints in your body to determine what the posture is. And I did some projects like that in the past, and combination of both gives you a really good result. Although getting the joints of a skeleton usually requires machine learning, but detecting the posture might not necessarily require a machine learning once you have the skeleton of the person.
Okay.
We have an AI that processes email invoices using the UI. That would be interesting to hear how this is being used. We do use invoices with form recognizer to get data out of the invoices. It would be interesting to know how do you process, what do you do with the emails in conjunction with AI. So a lot of things you can do with text analysis, and if there's any images or attachments, you can do a lot of things with it.
Gary, it sounds like a good topic. You have a good topic to actually present at our user group session if you want to come along. We'd love to know more about it, like what David JK is suggesting here. I would love to see how it works.
Yeah, we're also organizers of the Brisbane AI user group, but if it's outside of Brisbane, that's fine as well. We can host you as well. And yeah, we would be interested.
Is anyone else using? Is anyone working on driverless cars at the moment, or automated cars within Australasia? Are there any cars being built, or do you guys know if any cars being built in Australia with that?
Haven't heard about that yet.
Okay, we're almost there. Okay, I just need to. It requires a little bit of manual work, and I want to get it right. But just give me a minute, and we'll have the winners already.
Yeah, we just shared the URL to the meetup that we have. We didn't have the meetup this month because we had the virtual AI Bootcamp, but next month we'll return back to schedule.
Actually, that's a good thing to ask, guys. So in terms of the the user group we'll be running next month, so like I mentioned earlier, we've had sessions already from Microsoft, AWS, and Google. Do you know of any providers? I think we've been put in touch with, or we've been told that there's VMware that has an AI group as well. So they provide AI solutions, which we weren't aware of. Do you know if any other AI providers that are out there that provide solutions in the AI field, apart from these big four vendors that I mentioned just now? No?
Yeah, one of the more awkward parts of the having a stream like this, where we're streaming directly on YouTube, we can easily add people to the conversation and enable their mics. But we have an answer from Peter QUT are doing autonomous cars projects. So that's interesting. Would be interesting to see how they progress.
Yeah, it'll be good to reach out. Peter, if you know anybody at QUT who is doing this, you can if you can put us in touch with them, or alternatively ask them to come along and present. That'll be good as well. Just so that we get a broad view of what's happening in AI. I'll be very much looking forward to getting in touch with you outside of this bootcamp, so we can talk a bit more.
Yeah, I'm currently on the website, and they seem to be doing a lot of robotics.
Okay, guys, so we have the winners. What I'll do actually, and the winners are. I'll go for the first one. So Warren Finch, Mike Shaw, Madison, Gary Lewis, and Bertus Viljon. Okay, those are the winners. So what we'll do actually, we'll be in touch with you. We have your email addresses, so we match pretty much the email addresses that you used in Eventbrite, so everything matches. So for Warren, Mike, Madison, Gary, Bertus, we'll be in touch with you to give you that JB Hi-Fi gift cards of $50 each one of them. So that's amazing. Well done. Congratulations, guys. Thank you, actually. Thank you to all of you for joining the event. The videos they're going to be up in the Global AI Bootcamp YouTube channel. So give us a few days to be able to edit them a little bit, but they'll be there shortly, potentially next week or the week after.
Yeah, and also thank you for all of the sponsors for sponsoring the event, and thank you for coming.
Thank you for the speakers and the attendees as well for tonight or for today, and taking the time out, coming out on an early Saturday morning.
That's a good point. I mean, thank you to the speakers today for contributing to the community. Thank you to the sponsor. Thank you to BitQ, MOQ Digital, and Queensland AI Hub. So I think that's all from our side, guys. So we'll be in touch with the winners. If you have any questions, you know where to find us. We're the organizer of the Brisbane AI User Group. Looking forward to seeing you next year in the physical event, or we'll have a virtual event. Whatever we need to do, the AI community will continue running. Okay. Awesome. JK, thanks a lot for all the hard work that you put in. The same for you, Sarat. Pretty much we'll wrap up, guys. See you next year.
Thank you very much, guys.
See ya.
See you next year.